All right, class. So today is tuning, and I'm sure you're all very ready for the class today. It's not gonna be a teacher-student thing. It's gonna be, collective effort. We are gonna be teaching today, okay? Because I know you probably know more than I do right now. So performance tuning, like you probably already know, a set of techniques that is deployed in the system. And when I say system, we're talking about BW, to enhance performance, to make your reports, run faster, and then to make your data loads get into BW very into performance tuning. But as far as our BW expertise is concerned, we're just going to focus on the BW piece of it. Okay, but when we talk of performance tuning, it's broader than just BW. And if you remember, I had said earlier, in previous classes, the earlier sessions, that this whole BW thing, or this whole professionals also on the job, most times you find basis guys, functional folks, and you find technical together, you know, work towards the same goal. Because the end goal or the main reason a business would want to spend so much on a software like this, they get good reports and be able to make decisions, proper decisions, guided by facts. And in getting that, it's not just a one-way thing. It's everybody working together, doing their own piece of work, and then fitting everything together to get that end goal that a company is interested in seeing, which is queries. Okay, so a lot goes into performance tuning as far as the holistic view is concerned, because every person can do your part of performance tuning. If the basis guy does not tune the system, does not make sure that when you log into RSA1, it doesn't take 30 minutes to open up. Because if it takes 30 minutes to open up, obviously your work, and before you know it, it's a ripple effect all the way. Database that other guys do on their end, and then we most often do the application part of it. Okay, because that is what we do. We don't really database. And even though we make such instances, our main focus is mostly on the application side of things. Okay, so as far as BW is concerned, performance tuning is grouped into two main. There's query or report performance, and the other part is data load performance. Okay, so it's either how loads into BW or how quickly you can retrieve your data out. So it's data in, data out on as BW consultants. Okay, so let's take query performance, query or report performance tuning, and let's see what technicalities go into that. Okay, so there are a number of techniques you can deploy to make your queries respond very fast. And as far as I am concerned, that is, a big chunk of performance tuning as a whole. Load performance has a number of techniques as well, but if you can get your loads into BW very quickly and you cannot retrieve them out quickly, it's still not very good, because what users or what business is concerned with is not how you're loading your data, it's how you're running. They don't care about cubes, they don't care about data loads, they don't care about all that. So, that kind of performance is for us, the technical people, because it's nice when you can quickly load data. Okay, even though the ripple effect is, it might, end up, it might result in you finishing up your work very quickly. At the end of the day, what users or what business is concerned with is, and I don't see a business user, a report user, go to run a report and will be very excited, after having to sit there for an hour for a simple report to open up. It doesn't matter how nicely you design the report. It doesn't matter the fancy stuff you've done in the report. If it takes the user forever to run the report, the person will be so pissed, and they will not be so into your report. They will not be sold into this whole software thing. So query performance is a very, very important aspect. Okay, so we never take that lightly at all. All right, so many techniques go into that, like I've already said. So we're going to take the first point, which is sound data, and we are going to talk about that. Okay, so it's going to be more saying, because I know you've, had you go over last class, you're very cognizant. So what is sound data model? When somebody comes in and asks, what is sound data model? Sound data model is simply, in my own terms, how efficient your designs are or your models are. Saying, a model can be, right? Let me quickly get into the BW system. This is your class info area. You've all done, different modeling. You've modeled an info cube, you've modeled the DS. So all these are models. Okay, but which of your most important thing to put all your effort into enhancing performance on? I would say that, everything is important to do, but I would say that the most important model you need to focus more on is the direct info provider your queries are retrieving data from. Having said that, it doesn't mean that you should not pay attention to your DSOs or to your info cubes or to your master data objects if they are not the direct info provider feeding your queries. Okay, that is not to say it makes sense that you would fine-tune or you'd make sure to do a good data model for the info provider that is gonna that you're gonna build your queries on. It just makes sense that way. Okay, so mostly on the job you'd realize that cubes and multi-providers are the most used info provider for reporting. And again, that is not to say that you cannot use a DSO or master data object for reports. You can. And there are differences as far as your okay, so depending on what your requirement is, you'd use one over the other. Okay, but most often than not, you find queries being run on cubes or multi-providers. The reason being they are better for performance. Okay, they are better for performance than any of the underlying info providers. Why do I say they are better for performance? There are so many things you can do to a cube as far as performance is concerned against a DSO. A DSO does not have too many performance tuning techniques you can do to it. Okay, a cube has a number of them. So if there are 1,000 ways of making something better, against 5 ways of making something better, which way would you go with? You go with the one that has 1,000 options. Okay, that means that you can actually make it very, very sound. So I'm going to focus the sound data model on an info cube. Okay, and then we will talk about the DSO as well. But let's focus on all the energy on an info cube as far as data model. Okay, so let's take one of your info cubes and let's see how the structure is like or how it was designed. So this is Adewale's info cube. So you have a number of dimensions. You have customer, and all these are custom defined. These come timing unit. So the about that. But you define the customer dimension, like define the sales rep, and you know that ID. Okay, that is very good. So I have a question for you. Why did you choose to have 3 separate dimensions for all these 3? You know, instead of having them in 1 dimension. Is there a reason you did this design? Or is it even possible to have all these 3 in just 1 dimension?
It's possible to have them in 1 dimension, but I guess it's not advisable because that will, I guess when you put them together, you create a Cartesian product rather than just, I forget what the addition of the 2, the Cartesian of the 2 in terms of rows of data. So this is kind of more efficient. Not that I knew that when I created it, I was just following the videos when I created it, but after watching the performance video, this is the way to go.
Okay. Nice. Wow, you're already using the jargons. I like that. Cartesian product. What can you tell us about Cartesian product?
Okay, for Cartesian product, if we have 2 dimensions, the row count of your data, if you put them in the same dimension, it's going to be the number of customer information times the number of sales rep information. Rate the I keep forgetting the name, but when you separate them the way that's showed on the screen, instead of having customer ID times sales rep ID and the number of rows, it's going to be customer ID plus sales rep ID, which is less data for us to scan through.
That's great. So what you're saying is, if you have customer ID and product ID in 1 dimension, let's say you put all these info objects in 1 dimension, the customer dimension, it is going to give the Cartesian product, meaning that the number of records in the customer, you know, will multiply the number of records in the product ID, right? So if, let's say, customer ID has 10, 10 records, product ID has 20 records, it's going to be 10 times 20,
Cool.
right? But if you split them up into separate dimensions, they sum up. So it's going to be 10 plus, which is much lesser, as far as volume is concerned, versus putting them together. Was that what you're saying?
Yes, thank you.
Okay, so that is very right. Okay, and that is the reason you have to understand what goes on in the back. You have to understand the concepts of know when to put objects together in 1 dimension or when to split them apart. Okay, so to further explain that, at this point again, anytime you have a dimension, okay, that has a number of characteristics, and it does not mean that you cannot have a number of characteristics. Okay, I think Free or, I don't know, one of them mentioned that a dimension can contain 248. How many characteristics can a dimension contain, guys? This is an interview question. Quick, how many characteristics can a dimension contain? Anybody?
I think it's 248, and it might be 233 key figures.
248. Okay, great. So that means that it is possible to have that many characteristics in a dimension. Okay, doesn't mean that it is always the best thing or it would always degrade performance. There is no clear-cut answer to that. You can probably have 200 and a number of characteristics in 1 dimension. Let's say you can have 20 characteristics in 1 dimension, and you can have 2 characteristics in 1 dimension. Okay, but the one that has 10 characteristics, it is possible that that would perform better. It would not be more than 10% of the fact table against the one that has 2. So it totally depends on the nature of the object you have in the dimension. I don't know if you got my point clear, but let me repeat that again. So what I'm saying is, it is possible to, for instance, let me go to change mode and attempt to add more. Okay. Put customer CD ID and then customer name CD ID. Let me and put in more customer related objects. And I am gonna enter that ID. Let me put material maintenance product. Okay, let me put these two in one. This one, let me do employee ID and products. Okay, so guys, let's talk together. What do you think about these 2 dimensions? This customer dimension has 1, 2, 3, 4, 5, 6 characteristics in it. And this product dimension has just 2. Just need a yes or no answer, okay, whether true or false. So I am saying that dimension has more characteristics in it. It will definitely be more than 10% of the fact table. It will contain more, it will be high, in volume against, compare that to the product ID. Is that true? True or false? Snap again, let me know. Question? True, okay. So okay, you're saying that customer dimension would definitely be more than 10% of the fact table, and it will be more than the product ID. Okay. Any other answers? So something explain why you said true.
Well, I guess the customer dimension has more characteristics, and they're more than the sales. More data would lie under the customer dimension.
Okay, that's what you think. Okay, great. I can, disagrees with Ikria. Can you speak up? Ikria, thank you. We'll talk about it. What do you think?
Lean more on what Akria said. Just you have more and customer sales on products, right?
So you think the customer will be, will degrade, the customer dimension will degrade performance against the product ID dimension. Okay. Any other answers?
I think the product ID will have more information as compared to the customer.
Okay, why is that?
Because in product having two different dimensions, product ID and employee ID, and in the customer you have only one dimension, that is actually characteristics. Customer ID that has the same information about customer. In product ID and employee ID, they have from two different dimensions, two different characteristics.
So yes, Can is right answer, and that is the right way. Products we're talking about, or the the dimensioning, sizing we're talking about, you need to understand it very well for you to know that which one will be more than that. So making it sound more clear to you is, if you look at this dimension, right, even though it has a number of characteristics, they are all customer related. It's a one-to-many relationship. So it's the same customer information. Customer one CD, customer one name, customer one state, customer one telephone, customer one zip. Okay, so let's do this. Let me pull up an Excel sheet. That'll probably help. Okay, so what we have in this dimension, city name, state, telephone, zip. We have customer name, customer city, state, customer state, customer telephone number, telephone, and customer zip. Okay, so name is, let's say, clear. No, 001. Houston. Okay, so in this dimension, this is what we have. Everything is lining up in one line. An example of how this is going to look like. So let me actually add one more. I'm going to do can. Atlanta, Georgia. And okay, so this is a table. Let me do this table. This is table 1. I have the product dimension over here. So we have product ID and employee. So And we have employee. Shirt. Ade. And we have TV. And we have TV, and we have let's say free. Okay, so this is another. Okay, so we have two separate tables. Okay, so I need you guys to tell me, for the first table, the customer table, how many different ways can you regroup this? How many different ways can you, what will be the best way to say? How many can you remap this data? So can you have can being in Houston, put in, will it make sense to have combine can and Houston together? Okay, let me try and rephrase the question properly. Maybe we should take this first. This to probably help. So with this table, the product and employee table, the different ways I can combine this data will be, I can have employee Ade buying a shirt, which is the first combination, and then I can have employee free and a TV, and it would also make sense to have, oh, sorry. So it was free a day again by TV. That's an, and then it can also make sense to have free buy a shirt. Right? This makes sense to come. It can be a many-to-many relationship or whatever. Okay, these are if it doesn't make sense. And for this, if I think about a logical way to differently, the only thing that makes sense, just have customer one, and the curious information cannot, even if it changes, it will still override this. Okay, so a curious information will always be clear information. A clear city will always be Houston. I cannot say, and actually to even make it better, let me actually put the ID first. So customer one, really, your name would always be the same. If it changes, it will just override it. So customer one, it here, it will not make sense. Okay, so whatever is in the underlining table right now is Houston. That's the only way you can combine it. And I can only put customer 2 over here as can. I cannot put Houston over there, else it will not be wrong data. So the only possible ways to combine, the only combinations you can have for this table will still be the same. It's just two records. Exactly the way it is in the table is exactly how you can combine it. If you try to physically relate, it will not make sense. Okay, so if I choose to put customer 1 here, Ikria, and then Atlanta, no, it's wrong data. And in the underlining table, customer 1 city is Houston. It's not Atlanta. Combine it like that. It's not this. Not even combine it like that. No way to combine the customer table. It is just 2 ways. Okay, which is exactly the number of records you have in the main table, which is 2. You have 2 lines. Combine them is 2, exactly. But over here, you realize that I have regrouped them into 4. And you have products and you have employee. Okay, one employee can buy 2 products. Okay, so Ade can have shirt and Ade can have TV. And Free can have TV and Free can have shirts, and it will make sense. So you see the different combination I've done. So this is 4, and this is. So if you're giving the Cartesian product, if you're multiplying them, if we say, remember we said if you have dimensions in the same table, dimension, it multiplies up. If you have this, it adds up. Okay, sometimes depending on the nature of whatever you split, it will not make any difference. Here, the Cartesian product, it's 4. 4 different ways you can multiply them. 4 different ways you can combine them, just 2. So even though you have, this will be against this. Okay, does this make sense? Guys, let's talk. Does this make sense, or yes, I did.
I see what you're talking about now. It's in the customer table. Key figures are, you have the key figures and the related attributes.
Did you say key figure or key characteristic?
Oh, characteristics, sorry.
Okay.
And the attributes, and that's the product and the employee, they're independent, and you can combine it. It makes sense to combine them.
Okay. Yes. So usually when you have a key characteristic with its related information, and you cannot possibly regroup them. You don't have Can and Houston in the table, so it cannot. The system cannot have that combination. It cannot exist. It's as you have a day shirt and a day TV combination. Yes, it is possible because they are totally unrelated. Okay, so if I was creating a sound data model for this cube, and if I was redesigning this cube, it's okay. I'll just leave, even though this dimension have all these characteristics, it's okay to leave them there. It will not impact anything. It will not grow, in volume, exponentially against this. So I would rather split product and employee into 2 separate dimensions. Okay, it makes more sense to split product into 2 separate, employee separately, product separately. This is the customer. And this is just a simple table for product and employee. Can you imagine you have 1 million employees? Can you imagine the different possible combinations you can have, or what a Cartesian product will be if you put them together? That is going to way too much. But if you have 1 billion customers and they have other related information, it's just the way you can comment. The way it is exactly how it will be. You cannot regroup. Makes sense. Case address changes, what they do in the underlining table in ECC is that they will go and update it. They will not create another ECREA again with a different address. You can regroup them. You can keep history if you want, where you want to see where, or let's say case, she got married and her name changed. And you want what her name was at a particular time period. You can use, time dependent attributes. You can, but in the main table, it will still be the same line. Okay, it's just the stored in a certain way for you to be able to track history. So, and chances are, You will not just have TV and shirts as products. Okay, so there are certain objects, okay, and it will come with experience, but there are certain objects, immediately you see them, you know that this is a good candidate to just be in a dimension. But a few of them. Okay, so anytime you spot them, you know this is a high volume data. It has to be in a separate dimension. You cannot combine that with anything at all. So let's see some of them. Okay, now do that is anytime a dimension is that much in volume, it grows, it gets closer to the size of the fact table. And anytime it gets closer to the size of the fact table, it is not good on performance. So you realize that some books will say that dimension table should not be more than 20. If you want the size is between 10 and 15, more than 20, you want to make sure that you do something differently to it. Sometimes you cannot do anything about it. You need that dimension. Let's say we need product dimension, and product it's in volume. Let me take employee out. You only have one characteristic in this dimension, and it's still very huge. You still check, and there's a way to check URSRV, or there's another T code. I think we'll look into that. From experience, you can tell. You can even check, your ECC underlining table and see how much data records are there, and you can have an idea. But let's say, for instance, and for sure, in your queue, because you need to report of it, and the number of that it's more than 20% of your fact, and really there's nothing you can do about it. It's just one characteristic in that dimension. You cannot take anything out. If you take it and you're not going to have that dimension at all. You do to objects like that, to dimensions like that, you can just line item dimensions. Okay, when you flag, what happens is that see that dimension in your cube. So when you flag it, this product dimension will not disappear. It will still show. But in the background, what is that dimension table will not be there. In the background, it will not be there. You will get rid of that dimension table. Because all these dimensions have tables. Okay, I don't know if you've ever attempted to delete data in an info queue before. It would ask that, do you want to... So all these dimensions create underlining tables for you. Like a dimension as line item of its dimension table. And what happens is that it writes the sets directly into your file. And this is the rule of thumb. Anytime you have your sets in your fact table, or you have your objects closer to your fact table, performance is always better. Okay, and another way it also helps with performance is that you join. Because anytime query is being retrieved, right, it has to hit the fact table and then go into the master data table, or however way those data, the other processor has to hit to get you your data. Fact table, dimension table, and your master data table. But if there is no dimension table, it's just like, let's say, here is in the middle of me and Khan. Okay? And Ikea stands in our middle. And I want to reach out to Khan. I mean, I have to go through Ikea first, right? But if Ikea is not there, access to Khan will be way easier. It will be easier to reach Khan, and it will be easier for Khan to reach me too. So communication is much faster that way. But if Ikea was in our middle, I definitely want to Khan. So the same logic applies over here. If you don't have a dimension table, it's much faster, because you save yourself another join condition. Come and pick data and then join it to whatever fact table it is. That it's saved, so it's much faster in that sense. Okay, and I know when you're covering your cubes, I'm sure Evans mentioned to you that a simple star schema. This is how a simple star schema looks like. You have your fact table surrounded by your dimension tables, and what connects tables are your dim IDs. Would reside in your fact table. That is where they sit. And your dimension tables is connected to your master table, your master data tables via the SID IDs, the surrogate IDs. And the SID IDs reside in the dimension table. Okay, so because there is no dimension table anymore, when you flag a dimension as line item, automatically right into your fact table. And the table closer to your fact, that is it's much faster during query retrieval and even in data loads. So this point, it's one of the techniques that is good for both query response time and data loads. Okay, it helps with both points. How do you flag a dimension as line item?
Eva,
Yes, sir.
I have a question.
All right.
What is the measurement criteria that you said, oh, my is 10 to 15% less my factable? How do you measure your factable is getting larger?
So that's what I was saying when we'll see that. There is a transaction you can go to and it will tell you the size of your dimension table against the fact table. I think it was in the other video. Did you see that? Do you remember what T code it was? Can you remember?
No, actually. No, actually, it is my confusion, actually. When I talk about the factable,
Okay.
so in the factable, we have the key figures,
Right.
And when I talk about dimensions, we have, information about the dimensions. I'm really confused about, the size of the factable and the dimension. I understand a dimension, When I talk about the factable, I just multiply or plus minus to get my key figures. So how it impacts your factable when you have, dimension size increase more than 15%? In what sense?
Okay, I'm not quite understanding your question. So so fact tables have key figures and dimension tables have characteristics. So you're saying that how are they measurable? Is that a question?
Yes. Yes. How can I measure that? Oh, my dimension is getting larger as compared to my factable. How do I know that?
Okay. Underscore designs. I hope it's this. Underscore design. I think the Z code is it's a program SAP underscore info.
I think it's SAP underscore help.
Is it help underscore info cube underscore designs, I think.
I think that T code didn't work when I was looking the earlier videos actually.
It didn't work? Okay, so it's actually a program. So you go to SE38 and run this program. So the program is, let's do it again. /n SE38 it brings you over here, and then there's a program, SAP underscore InfoCube underscore designs. You execute it. And then over here, it can give you an idea of the size of your dimension table. So let's take the cube we're working on. So the name of the cube is Z, and this cube, right? I don't want this cube. Z02SIC, Sales Info Cube. So let's scroll down to the Z's. Let me know if you see it. We can probably find. Okay, there we go. All right, so this is a cube, and this is so every dimension have their name. The dimension table product ID is Z02IC3. Okay. This is the info cube, and this is the dimension name. He only has 3 dimensions. That's why you see 1, 2, 3. This is the data packet. This is the time dimensions over here. Okay, so the third one is the IC3, and IC3 ratio is just 55%. It's 11. Ratio is 11 and it's 55%. Hold on for me, guys, 1 second. Okay, so this is it's 55. That's totally not right. So let's see what his fact table size is. Let's see what he has in the fact table. He only has 3 characteristics. Okay, and 3 characteristics. Okay. So this, whatever volume is in here, is definitely more over here. If you have something 0, it's good. The ratio is 11. It's not, I mean, you can pass with that. But this is where you come to give you an idea. Another place you can go to is RSRV. And you can do the fact table to dimension ratio combinations. Over here, you can come to all combined tests, and then you go under transaction data, I think. And then you have consistency of the time dimension for all info cubes. No, that's not what we're looking for. Fact and dimension tables of an info cube. Okay, so you can double click that, expand this, and then you can put in the cube name. And you can do transfer. And once it transfers, you can execute it over here. The year of, your cube. Let's see where. So let's compress fact table. Okay, this is how it gives you the ratio. Let's come on the aggregate. Elementary tests. Fact and dimension table of an info cube. Comparison of number range. This is also another place you come to for performance, and we'll talk about fact and dimension table of an info cube.
It should be under database, yeah? Because the information should be in database.
Let's see what we have in the database. Oh, I got it. This gives the indices for row compression. There's something that should give the ratio. There is an option. Sure. I must have covered it. I don't know if you guys went through it or bad. If you go through that again, you'd see it. It's just hiding somewhere here. No, it won't be aggregate. Wait, let's not waste time over here. We'll come back to. I'll try to remember which option it is. But there are two places you can find that out from. You know, you can run that program, or you can come here to give you an idea what the ratio is. Okay, and like I said earlier on, to experience will also tell you. Experience will tell you. And you know that you will be safer. You will for sure be safer if you don't do, you know, high cardinal objects in one dimension. Be a lot of trouble. Okay, so turn all these many to many and one to many relationship. Okay, in determining. So like I was saying earlier on, if let's say for instance you only have one dimension product ID and you haven't put any other characteristic in, it only has one characteristic, and that dimension, like we checked, is growing. It was like 55%, right? And there is nothing you can do about it. You cannot take action. How do you make it perform better? You can dimension, or you can mark it as high cardinal. Okay, so how do you do that? You can stand on the dimension and right click it and do properties, and over here you can choose. And the reason line item is grayed out is because we have data. We've already loaded data. You cannot come back and redesign the line item. You have to take out the data first before you can. So it just modeling, you have to put all these into consideration before modeling. Okay, because time is, and really that is what a good consultant will do. You have to understand what goes on in the background when you're designing, and then design with performance in mind. Because at the end of the day, performance would always come in handy. Certain things you can tweak them with time, because it doesn't make sense to keep to enhance it initially, but after time things degrade. So certain performance techniques, it only makes sense to do them after a certain period of time, but it makes sense to just do them on the start right away. And this is a typical example, to relate to that. If you're a baby, I haven't seen any mother apply a wrinkle-free product to a baby's skin. They will not do that, because a baby's skin will not wrinkle. It just doesn't make sense. They have first and clean. They're probably old. Okay, so at a certain age, it just makes sense to start applying that yourself and make yourself keep looking good. over here. In doing data design, certain things have to be applied on the right, right on the onset. Like the baby, if you want to enhance the baby's growth, right when you give birth, right on the onset, you give the baby, or you want to make sure that you give the baby more proteins to grow well, right? Would you give the baby a black tonic? Probably no. So you have to understand what on the onset when you're designing and what needs to come later. Period. Line item dimension, high cardinality, some of the things you on the onset. How to dimension, how to put in the a number of characteristics, or how to do your dimensioning. You have to decide that on have time to come back and redesign this. And for instance, let's say you have in your cube, and you just realize that, oh, product ID dimension needs to be flagged as. So if you're running reports of that cube, you can't go and delete that data. So that means that you're something you can do. So make sure you understand this concept before building. Okay, so you have two options over here: line item dimension and high cardinality. They cannot do the same thing. The difference is that when you flag, it does not get rid of your dimension. Is that it just puts a flag on that dimension as a high cardinal object. And all that high cardinal means is that it's, hey, it just tells them, hey, watch out, product ID dimension is going to be high in volume. It's going to be very, voluminous data coming in. So watch it. Asking that how many line item dimension let me read the question again. So Khan is asking that how many line item dimension can you define for an info cube? How many line item dimension can you define for an info cube? I believe you can define as many as you want, and we can try that. But just note that when you as line item, you can characteristic in that dimension. You cannot have two. So for instance, if you wanted to flag the customer dimension as a line item dimension, it can only contain one character: customer CD, customer name, customer state, telephone, zip, and the ID all together. It will not let you. Okay, so to try that, let's actually go and delete this data first. Let's go and delete the data in Adewale's delete data.
Yes, I think $50.
Okay, Khan is gonna pay that. He asked the question, so can you owe Adewale $50? Okay, so I'm gonna delete the data and see what it says. It says, do you want to delete the contents of data target? Yes. And then it asks another question: do you want to keep the data in the dimension tables? So this was what I was talking about. All the dimensions you define, they have the underlining tables for them. Adewale, Khan says he's going to pay you from his first salary. He's going to he's going to double the $50, probably triple it. So do you want to keep the dimension tables? We don't want to keep the data in the table, so I'm going to say no. Okay, so we don't have data. So customer, oh, I should have saved the first one. But that's fine, we can do it again. So first of all, we want to try if we can have a number of line item dimensions. Flag this as line item. And then let's flag the product ID as line item too. Okay, and let's do a check. Let's see if it complains. So it didn't complain. So Khan, to your question, yes, you can have a number of line item dimensions. Let's try sales rep as well. It didn't complain. Check was successful.
What is the, what is the ideal, ideal condition that
Ideal
can realize?
Ideal condition, I would say 1, because you remember that it has its pros and cons. Okay, flagging something as line item dimension and not flagging it as line item dimension. So I would not want to flag everything as line item dimension, but if it comes in handy, if it is, I guess you might as well. But for all these years I've been working, if I have to flag anything as line item, it's mostly been one dimension, and that dimension that is really necessary to flag. Okay, so successfully without any issues, and all the 3 dimensions are line item. And you realize that the dimensions did not go away; they are still showing. Okay, so it is the takes care of the dimension table. All right, so let's try one more thing. I'm gonna unflag the customer back. Or let me not even flag that. Let me attempt to put a number of characteristics, and let's see what it says. It will complain. I'm gonna put city. It will go, but when we try to activate it, it will not. Let's put name. And let's telephone and zip. Okay, and let me do a check and let's see what. You see the error? It says line item dimension contains more than one characteristic. One characteristic. So that means that when you flag something as line item, the downside is you can only characteristic in it. Okay, so and let's say customer dimension, you need to put in certain things in there. Okay, and we all know that we can only have 16 dimensions. And I need us to reason through this together, because sound data module, a lot of reasoning should go on. You need to think through a lot of options and weigh all of them and choose the best option out. So let's say that we know for sure that we can only have 16 dimensions, right? 3 of them are automatically created. So that means that we only have 10 custom dimensions to have. We create 13 custom. And you have in your data source, you have a number of info objects in them, and you want to group them into different dimensions. You've used up all the 13. So you have 13 dimensions. You've used all of them up. And or let's say you have used up 12 dimensions used up. And oh no, okay, no, let me not do that. Let me say you used up all the 13 dimensions, okay? And info object to define. But you've used up all your 16. The 16 is totally gone, but you need that object in your report. So that means that it has to somehow be in your cube. Okay? And that object, you cannot, depending on the nature of it, you cannot combine it. You can put that if they are not related. Okay, to even make this look better, let's do this. let's say this dimensions you created are customer. Okay. So let me do this as dimension. So this is, and whatever is underneath it is your characteristic. So dimension, and then this is the object. So in your customer dimension, you have customer ID. And then let's say you have material dimension. ID there. You have employee dimension. Okay, so let's say everything you have their IDs. Okay, so let me just put IDs so it'll be easier. Customer material employee, let's say you have document number. Of your organizational data. Okay, let's just, for sake of time, let me just put anything. So you have all your 13, it's all used up. Okay, all these are different dimensions. 1, 2, 3, 4, 5. Let me do 6. Why did
You have to click on the plus sign down. Down there. Yeah,
but
fill
usually when
series.
I drag, it just, okay, so you've used that whole thing. Let me take out these. Okay. Okay, and these are all IDs. And you have one more info. Okay, and that info object you need to put in. So all of these dimensions only have their IDs. Okay, and they are all very unrelated. So you cannot put material ID into customer dimension. Okay, because it's not good. The only dimension you have is, let's say, sales rep. Or to even make it better for you, okay, let me make it very easy for you to guess. The only dimension you have left is cost address. Okay, you need that in the report. So somehow you need to fit it into all these. And all these, the customer dimension, even though it only has a customer ID, it's 20, let's say it's 20%. 20%. Oh, what's that percent saying? Okay, so customer dimension is 20%. And all these are also, they are all 20%. Okay, everything is 20. But you have one more info object to put in the queue. And this is logic, pure logic. What would you do? You cannot create a separate dimension for this because you've used up all your number of dimensions. You can have a separate dimension.
So use as an info object characteristics.
You need to put in a dimension some way, somehow. So what would you do? I like the way you guys are thinking. I like your answer very well. Okay, so Roxy, you're saying that can't it be a subset of customer? Yes, so subset of customer, what are you saying? So what is that? So when you say subset of a customer, I'm not clear. You mean putting the customer dimension? Yes. Okay. So if I put it in the customer dimension, to it. Okay. What different ways do you think I can have this customer address in my, available in my report without, impacting performance?
So you can use as a navigational attribute.
Thank you. You can use it as navigational attribute, or you can choose, and the reason I actually came over here was this flag it sometimes line item. Okay, so let's say that this is 20%. You want to make it navigational because everything says that if it's more than 20%, then flag it as navigational. Flag it as line item. What I would do is, if I wanted to put in a not flag this as line item dimension, even if it's 20. So customer, if I'm going to put ID and address in one dimension as line item dimension, I will just mark it as high cardinal. I'll just mark it as high cardinality. I will not flag it as line item because immediately if I flag it as line item, was this not what we deleted the data in? Or did I activate it? Sorry. Why is the line item hidden? Okay, so what I was saying is, let me get out of this queue. If I wanted to add the address to the customer ID, what I'll do is I will not make it line item, because if it's line item, you will not address. Okay, you cannot make a line item because you need to put in another object in it, and it's still 20%, and you want to make it perform better. The other option you can do is you can do the high cardinality, because when you do that, it kind of also attaches some kind of performance tuning to it. And the advantage of this over the line item dimension is that you get to put so many, or you get to have more than one object in the dimension. And it still does something for you as far as performance is concerned. On line item dimension and high cardinality, what the difference is? Any questions on line item dimension and high cardinality?
Because first you put customer as, because since you need one more characteristics in this line item, so did the characteristics again change it to high cardinality. So it's still,
No.
So it's become a dimension, or what happened?
Okay, so what I'm saying is when you're designing something from scratch, right?
Okay.
I'm not talking about when you've already designed it and you're coming back to change it. So when you're coming back to change it, I mean, you have to delete data first before you can take the line. So let's say that this dimension was originally line item dimension. I would now recommend that you change it because that means that you have to go delete data. You can have access to this dimension via the navigational attributes. Okay, so there are two options you can have this. Okay, you can have this via navigational attributes, and we'll do that. And so what I'm saying right now is when you're designing performance in mind, right on the onset. So if you're designing this, that means that you will need, right? Because every object in every field in your data source, and you need to see that in your report. You need some way, somehow, have it in your info provider. So you will know even before you design. And let's say that you know what you cannot combine together. So having a good idea of that, and you know that all the different dimensions you need to have a good design, you're gonna have to max out all the dimensions, all the 16. Now probably be left to be customer address. And customer address, even though the customers you have in your system, let's say you're a retail company, so your customers are huge. You have billions of customers, and just customers alone is taking up so much space. Is growing into the fact table. What can you do about it? You will not need to make a line item. Have the address as part of it because it's not going to make it grow any much. Okay, so add that to it. Flag this as high cardinality so that it just adds a little tweak to it for you as far as performance is concerned. Okay, so all I'm saying is that all these
my
two
question
are
is,
good for performance. Yes, sir.
the performance process, or if it's, performance comes after when it's in the production?
So that's why I said earlier on that there are some techniques that it has to be right on the onset of design. And there are some techniques that can only come after you have done design. Whether production or dev, it comes after the design. And remember the whole story I was giving about a baby? Like when you give birth to a baby, right? And you want the baby to grow up very well. Right on the onset, right immediately when you give birth, doctors will recommend that you start giving the baby protein. Okay, so certain things, certain performance, it has to happen right on the onset of design. Design with performance in mind. For instance, sound data model, it cannot be done in production. It has to happen right at the time you're designing. Other things like aggregates, compression, other techniques, or when it's deteriorating or it's degrading in performance. It will not make sense to apply them right away. Doesn't make sense. So, the big thing is understand what the techniques do. We all know that performance tuning is to enhance, your queries and your loads. And there are different techniques you can deploy. Understanding what each technique does will enable you to know that this technique needs to be done during design, and this technique can only be done in production, or it can only be done, after the queries are run. Knowing, the functionalities or the technicalities of each technique will enable you to know where to categorize them. Does that help? No? Are you more confused?
Yeah, sure.
Okay.
No. I'm just clearing my concept actually. Thanks.
Okay. Next point, and I think we are taking too much time over here. So the first point is sound data model. Understand that it has to happen right on the onset. when you're designing. So whatever you're designing, you have to have a, understand the implications before you design. And what we are focusing on right now is cube design. So when you're designing a cube, you have to design a cube with performance in mind. How do you design a cube with performance in mind? If you know that, okay, and how do you know the data volume that is going to come in from ECC? You can have an idea of it. Okay, if you know it's going to grow very much because you understand the company, you understand the business they're doing, you know their data, always make sure that you search objects into one dimension. That is, one of the performance things you should have in mind. Never group them together in one. And again, a dimension as line item dimension. Okay, so you decide. It's your choice. Do you want to flag it as line item dimensionality? The difference I'm explaining to you is that this all help with volume, but the difference is that high cardinality doesn't go. Line item dimension gets rid of the dimension table. Line item dimension, you can only have one characteristic in a dimension. High cardinality, you can have more than one characteristic in a dimension. Okay, so you pick and choose whichever one. Okay, so that's all there is as far as an info cube is concerned. Model it very well. And the other option, before I forget, in getting this customer address. So for instance, in case you flag, okay, that means that you can only have the ID in there. You cannot have the address, and you want to have address getting in via navigational attribute. So what that means is that if address is flagged as navigational attributes in your queue, okay, let me open another session when I go flag customer as line item. This is what you do. You have to flag the address. So this is customer ID. Adewale, I hope you have customer address in here. So over here he doesn't have address. I'm just going to choose state. By default, it comes as a display attribute. You flag it as navigational attribute, you can have access to that object in the query queue. Okay, so first of all, you have to make it navigational in the master data itself. So how do you make it navigational? You just turn this pencil on, and it switches from DIS to NAV, meaning that it is no longer a display attribute, it is a navigational attribute. You activate it, you realize that in the queue, so right now when I get under navigation attribute, I'm not seeing anything, right? Because before I open this queue, customer did not have any navigational attributes at all. Let me go out of the queue and get back in again. And then you realize that that navigational attribute will come over here. So this is the customer, the state we flagged. Now it's showing over here. So if you want to have access to this state in the queue, okay, let's say this is a line item, so you cannot put it in the dimension. Another way to have it is to flag this thing on as navigational. And once you do this, when you go to your query designer, this navigational attribute will show up as an info object over there. You can for your report, to design your report. Okay, so sound data model, you pick and choose what to make navigational, what not to make navigational in your queue. But as far as performance is concerned, the more navigational attributes you have, the lesser the performance. Navigation attributes are not good for performance. The reason is they do not physically reside in the queue. So the difference between having the address in here versus having it as a navigational is when you put the address in the dimension, that data will physically reside in the queue. Okay, when you flag it as navigational, the address will now physically reside in the queue. It is only in the master data object. Okay, so during the query runtime, or what the other processor will do is that it navigates into the master data object to pick up the address for you. To something, it's longer versus something physically there. So proximity in putting address in here is better. It's easy to retrieve that over navigation attribute because navigation will have to navigate into the master data table. Any questions on this? And I know, right now, back to play the video and you take your time to understand it, you will realize that it's a very simple thing. Okay, so know how navigation attributes impact performance and to use it and when not to use it. I will only use navigation attributes in a queue when I cannot have them in a dimension. Okay, say for instance, state is not in your extractor. It's not in your extractor at all. That means that you cannot map it. It doesn't have a source. The only way you can have it is via navigational attribute. That is the only way. Okay. And another importance of navigational attribute is it makes so you can choose to have a display attribute and a navigational. The difference is a navigational attribute will act like an independent object for you. You can create a variable on it and you can create a filter on it. You can do whatever you want to do with it, but then a display attribute, you will not be able to do that. Okay, and what I mean exactly is if you go to Query Designer right now, all the display attributes of customer, you will not be able to create variables on them. But since we have flagged states as a variable on states, we will be able to do that. Okay, so understand when to use it and when not to use it and all that. Okay, so I think that is good enough for sound data model. Unless you have any questions, I'm going to move on to the next point. Okay, and I was saying that there are certain things, there are objects that if you see them right away, do not combine them together. Evans put over here, material and customer should have separate dimensions. I'm going to put more for you. Another one you should know when you see them, just know that it's a candidate for a separate dimension. If you have invoice number, order number. Okay, you can add these two. Invoice number, order number, please make sure they are all in separate. Okay. All right. Any questions on sound data model? If there are no questions, I'm going to go on to the next technique, which is aggregates. Okay, so what can you guys tell me about and why do we use them for performance?
Hi,
Anybody?
Eva.
Yes. ESI?
They act as that's just like summarized view on an info cube.
Okay, it's a summarized view of an info cube. So can you explain to me how does that help? I mean, before you say that a cube also, is good for summary, right? A cube summarizes data. So if then you're saying an aggregate is also a summarized view, can you explain the difference? Like, what really is this summary thing?
Like smaller versions of info cubes. It helps in faster data retrieval.
Okay. Can you explain further? Yes, I get that, but how does it help with, how exactly does that happen? And anybody else can try. And that was a good try. Anybody else? How do aggregates help with retrieving data faster?
Because you can reduce the number of characteristics.
Okay. So that's great, right? That's good. Fewer records to search through, right? Okay. And, I think this design actually makes sense. Look at this. Oh, where did I go? This design of an info cube and an aggregate. Okay, so in the info cube, you have month, material, revenue. And for the month, you have July and September. Okay, for the month of July, for the materials, you have caps and nails. Revenue is 100 and 300. September, you have cap and nails again, and you have 50 and 30. And then in the aggregate, in the extreme right, you have month and revenue. Okay, so you have July and September, 480. So just tell me what you think. I mean, I think the picture is self-explanatory, but I want somebody to, make a very good try at this. Anybody who gives me the answer I want to hear, and you get $100 from me.
Is it basically a summation?
You said what? Okay, so the answer is expected here. Free, can you mute yourself, please? I'm getting a lot of echo. Okay. Yes. Look at the diagram and try to tell me or try to explain what exactly is happening in the background. Like, why should aggregates show 400 for, just, look at the differences and try to explain, try and put 2 and 2 together and try to figure out what is happening or what you think is happening. And then we will talk. And the reason I want you to do this is I think the diagram is very self-explanatory. So yes, before I start calling names, anybody?
Eva.
Yes.
Free. I think it aggregates everything for the month of July. Like the revenue is put together. For the month of July, it is put everything together. And for the month of September, it has put everything together. So we have a reduction of data.
Okay, yes, that is true. So why did it, so in the month of July, we're saying 400. Why was he able to put everything together?
Well, I think so that you don't have to search everything. Probably want to get, you want to do a query on go get everything. You just want everything under the month of July. I don't know. Easy retrieval data. I don't know.
Okay, that's a good try. I'll take that. Anybody else?
Hi, Eva.
Hi.
Yeah, it's basically a summation. Like in the cube, instead of going on each revenue, like in July, taking 100, taking 300, it'll be faster to have a summation of that in the aggregate, which equals 400. Individual, like the individual cut revenue and nail revenue, you have a summation in the aggregate, 400.
Okay. All right. I'll take that. Anybody else?
Yeah, did they remove the material column because I guess the report
Thank you.
isn't
Thank
really
you,
using.
Adewale. Thank you. That was what I was wanting to hear. But you kept too long, so I'm going to keep my $500. Yes. So I want you to be very, very observant. So, and Free, that was the question I was asking you, that why is July showing 400 and September showing 80? So the answer to that is it depends on how you define the aggregate, or what objects you define the aggregates with. And when we do it, you will see what I'm saying. Okay. You're showing 400 for July is because the aggregate was defined on month. The aggregate was defined on month, so it aggregates the months. So you have July and September as in the cube. Okay, so if you're the month, it just makes sense to sum up the month related information. Assuming this aggregate was not created on month and it was created on material. Let me actually put material over here. On material, then that means that for materials we're gonna get caps and nails. Those are the only materials. Nails and caps are gonna be 150, and nails will be 330. Right? So whatever shows up in your aggregate, totally characteristic you define your aggregate with. That is what determines the summarization for you. Okay, so what to define your aggregates with? It totally depends on what you want to enhance as far as performance is concerned, and I will explain that further. Okay, so does this make sense? So let's say, for instance, you're running your report, okay, and your report does not care for dates. They only want to see materials. They don't when not and all that. And in the cube, you have all your materials in the cube, different months or into the different time periods the sales happened. Ryan, you're only interested in seeing all your materials, in your system, and so if you create an aggregate on month, what you want, right? Because month is not going to bring you all your, it's not going to summarize the data on material level for you. Because if you check the two extremes, the material and month, they are showing total, right? They're showing totally separate revenue figures. So what do you want to see? What you want to see determines how you design your aggregate. Okay, so you will understand more when we create it. So let me just take these out. Okay, so back on the first one, let's see what is happening in the background. So in the cube, you have July split into caps and nails, and you have September split into the individual materials. Okay, find and aggregate on month and list the data for you. So what happens typically in the cube? Had you, let's say you're running your queries directly on your info cube, okay, and you're let's say you want to see your entire data, or you even want to see what happened, what sales happened in the month of June. Okay, what it means is that it has to do with in the queue to fetch the data for you. That means that the other processor will have to go data exactly what you want for you. Okay, so let's say you wanted, let me go back again. You wanted September and July data. Okay, but you're showing all through all the entire cube and get your data for you, and that will take much more time. So let's say that takes 60 seconds to get your data for you. And then you do an aggregate. In your query, you only wanted to see July and September data. You define an aggregate. So when you define an aggregate, this is what it happens. It aggregates them for you. So you have two lines. So the query, instead of going to the queue to retrieve the data, it recognizes the aggregate because of the way you defined your query, and then it goes straight into your aggregate and gets the data for you. But, you know, which of these two cubes, the aggregate and the cube, will be faster as far as the data retrieval? If, you know, what happens is that either way, it has to do a full table scan. Aggregate will still be faster, because if it does a full, it only has 2 records to look through, right? 2 lines to look. Cube has 4. So either way, the aggregate is going to be much faster to retrieve data from versus the info cube. Okay, so having said that, aggregates are like mini cubes, like you guys have already said. It's a subset of an info cube that has more of a summarized data view. For you. Any questions on this before we create it? Any questions? No, because it's very self-explanatory, right? So how exactly do you know when to design and to define an aggregate on an info cube, or when not to, and how does it really work? Okay, so what happens is anytime you define an aggregate on an aggregate is only defined on an info cube. You never define an aggregate on a DSO or a multi-provider or any other info provider. That, so help me create. Somebody asks you, you start working, somebody asks you, can you help me create an aggregate on a DSO? And calling me, you come calling me, either can you help me create an aggregate on a DSO? That is a no-no. When you think of aggregate, okay, so get that very well straightened out. So typically, when you have an info cube and you define an aggregate on an info cube, depending on what your query definition is, the aggregate will be hit or it may not be hit. It will be accessed or it will not be accessed. Let me take that again. Let's say, for instance, you define an aggregate based off on month. Okay? And in your query definition, material, the parameter you run your query by, materials and their revenue, no month, nothing. What is going to happen is that this aggregate, even though you have defined an aggregate on an info cube, when the query is being run, the OLAP processor will not access the aggregate because it doesn't see anything to access. The query line up with the aggregate definition. So it will still not give you good performance. Because it will bypass the aggregate and hit access the cube directly, because material is here in the cube and it's not in the aggregate. And you're interested in seeing material, so it will access the cube directly for you. And you'd realize that it would take as much time to, your aggregate definition will still not help with performance. So you realize on the job, people create aggregates a lot. They're creating aggregates to enhance performance. You find it wrongly, so it's not really impacting performance. You have to understand aggregate theories for you to be able to define an aggregate properly to enhance your performance for you. You creating an aggregate does not automatically increase performance or help your queries perform automatically. It depends on what in your aggregate. Any questions, guys, before we start creating it? No questions. Let's just go ahead and create it. Okay, so how do you create an aggregate? You start on your info cube, you right mouse click and do maintain aggregates. And you get this pop-up screen for you. Sometimes the system can generate proposals for you, or you can create it by yourself. I would always create it by myself because to create a very good one for me. And usually what the system stands on to generate proposals for you is the queries that have been created on that info provider. So it looks at the queries and then kind of guesses what you may need and generates that for you. But remember that you can have different queries on the same info provider that belong to the people. So you have one info provider. Ken can go create his query on that info provider. Ikea can create a separate query. I can create a separate query. Nations will be probably different. Okay, and I want to enhance my query, not Ikea's query. So it's likely that whatever the system will propose for me will be based off on Ikea's query, and it will not help me. So it just makes sense for me to create one by myself and define it specific to my queries. Okay, so by the choice is yours. You can generate proposals or you can create by yourself. I'm going to create by myself. Over here, remember that you will not just create aggregates for its sake, for creating sake. It always has to be to enhance query, some kind of query. Okay, and aggregates are for query performance. It's not for load performance. So depending on what query you want to enhance, you will have an idea how to define your aggregates. My queries, I'm running my queries by sales reps. It is the main driving parameter in my query. And it's taking forever because it's running, it goes through the whole, it does a full table scan before, my other processor gets my data for me, and I want that to be reduced. So if you're not interested in everything and this is all you want, then just define that data structure for this. Summarize it already in memory so that it will just access the aggregate directly. So to do that, you can do a create, give it any name you want. We can do aggregate 1. Long description can be aggregate. So over here, you can drag and drop your dimension in. Okay, so I mean, and that's for this aggregate. If you want to put a number of, or let's say you want to put customer in, and you define the aggregate just like an info cube, dimension, the way you do the dimensions is exactly the same way you do here. If you want to put in this sales rep, you can do that. Okay, so you can put a number of dimensions in one aggregate. This is the main aggregate. You can put a number of dimensions in them. Or you can create separate aggregates for this. So let's say, for instance, I wanted to create a separate aggregate for customers. Instead of putting all one aggregate, I can create a second aggregate and do customer. I can drop this dimension over here. So I have two separate dimensions, separate aggregates created. So you can define as many objects you want in an aggregate, in one aggregate. Okay, but that also will impact. Then we will look at the do's and don'ts in creating an aggregate. Okay, you'd always want to aggregate does not end up as big as your info cube. If it does, then you might as well use the cube and not create an aggregate at all, because what is the point? The main reason you're creating an aggregate is because you want a subset of the cube. You don't want to create another cube. So if all your objects, you define everything here in your cube as aggregates, it's going to be as big as your. Okay, so we'll look at the do's and don'ts. Anything you're not interested in, if you're not running your queries by customers, there is really no point defining an aggregate for that at all. So this aggregate, let's just have one aggregate. Okay, we only want sales rep aggregate. So once you're done doing this, you activate. Okay, and this, the status says red, and the field status also says red. Once I activate, the status is going to switch to red. Field may switch to green or red. If it's green, that means that the data also that we have to go do rollout, and we will go through the process of rollout. Or later. Okay, so you see that it's green. So that's good. The cube, we deleted the data in the cube, so when we did the rollup, it didn't have, there's nothing to push into the aggregate. So that's it. But when you create an aggregate, you still have to push the data from your info cube into the aggregate, and that process is called roll up. Okay, once you create an aggregate, data will not automatically feed into the aggregate. Data will not automatically be in the aggregate is still a physical data store, so it needs to have data physically residing in there. How do you physically get data into the aggregate? It's just as simple as pushing data from your info cube into the aggregate. And how do you do that? That process is called roll up. Okay, so we have defined our aggregate. If we want to go push data, that means that we have to go do roll up. How do you do roll up? Manage on the cube here. do a ruler. But right now we don't even have data in the cube. So let's go back and push data into the cube. Okay, I deleted the data because we were trying to do the line item dimension. I know there is data in the PSA already, but let me verify that. Okay, we have data in the PSA. I want to push these data here. Yes, I'm going to do something because the next topic I'm going to do is going to be compression. I want to push, so there are different ways in pushing this data into the cube. Okay, so I think that there has two separate requests. You can choose to merge all these requests and push them into the queue, or you can choose to push them one after the other as separate requests. I'm talking about. So first of all, if I push the data in the PSA into the cube, and I choose this option, I don't any option here at all. All the data will come together as one request in the queue for me. And what I'm going to show you, extracting that, you know, you need to, I mean, you don't need to know, but it's a plus if you know. Okay, so data got transferred. It says 20 and it added 20 to see what was in the PSA before. You realize that these were 1010. Okay, so it added up all of 20. So this request says 10. When I go into the other one, it will say 10 as well. So it merged all of them and pushed them as one request into the queue. Because I didn't specify to split it up. If you want to split them up into 1010, that exactly the way it is, comes into the queue, this is what you can do. So let me go into the queue and delete it, and then we will push it again request by request. Okay, so in the DT that to be updated. So I'm going to go into change mode, and over here I'm going to do get all new data request by request. Okay, so when you do pushing everything together, you are just bringing them exactly the way they are in requests, in different requests. I didn't activate. So let me delete this. Go back to the DT. And fully activate it. It's still on revised version. That was why I didn't do it. Activate it. Okay, it's active. Now we can execute it. So do you see that you have the 10 split into separate requests exactly the way it was in the PSA for you? Okay, so I'm going to leave this like this because I need it like this to show you compression. All right, so we have data in the to the aggregate. Okay, so we all know that the process in doing that is called roll up. So in rolling up, come into the info cube, do a manage on the info cube, come under the roll up tab, and then choose the roll up, just this request. Okay, the 10. You put that request ID over here and you execute. And once you execute, you come back to request and then you refresh. Okay, so roll up. If the roll up is done, so there are so many ways in rolling up. You can automate the roll up in the process chain and fill in that process type in the process chain. I think we did that last bit. Remember I told you when we're doing performance, we'll come back to process chain and then fill in all the little. Every time you load data, you always have to do a roll up. If you don't do a roll up, that data will not, and it's very important to remember this, okay? Because people don't realize that, and sometimes it buys them very much. Anytime you've created an aggregate on an info cube and you forget to do a roll up, even though your cube will have data, most often than not, that your queries will not show data. Okay, so if you have a cube, the cube has data, but users are combining data. First thing that should come to mind is, have you done roll up? First thing is check if the cube has an aggregate. If it has an aggregate, chances are you haven't done a roll up. So do roll up, else your data will not be available for reporting. Okay, so I'm going to go into what happened to our aggregate. Our aggregate did not create. So when you create an aggregate correctly creates, you see the aggregate signed by it. It. Or I probably did not refresh. Let me refresh and see. Okay, I'm still not showing aggregate. So let's go back and create it. So this is the. So there is something going on wrong here. Let me select aggregate and activate it again. Okay, so it says it's active. Let me get out, come back in again. Because sometimes it does that. But if you create it, that symbol should show. If it doesn't show, then there's something. And I know that in previous classes too, there was something wrong with it. Let me totally get out and come back in. Let's see. Switch to. Probably have too many sessions open. Okay. So let's get in. It still is not, the symbol is not showing, even though we have defined it. Because we have defined it, then it's. And the records are showing 0, meaning that it didn't. because it's not showing any aggregates to fill. Let me go back, do roll up one more time. If it still does not, we'll switch to the new system and try that over there. Okay, still not showing. Let me. And guys, make sure that before you highlight, it's always highlight. Before you activate it, make sure the aggregate is highlighted before you activate it. I was hoping this will show the sign symbol. You can see it is not showing it. Yeah, I will let Evans know, but let's move on. I will show you in my system in a little bit, but it's on a separate computer, so that means I have to switch. I have to switch presentation, and that means I'll show you exactly how the sign looks like. The sign looks exactly like this in here. Where is this? It looks exactly like this. The aggregate, the E. It looks like an E, right? Or whatever it's called. It would show. It should show by the Q somewhere over here. Okay, so that is what will let you know that this cube has an aggregate on it. So we'll see that in my system in a little bit. But that is all there is to aggregates. How do you automate the roll-up chain? It's a process type. So you go to RSPC. And oh, nice. You guys have created chains. That's very good. Okay, so if you want to introduce the roll-up process type, it's over here. And you see they all look the same, all these three, which one it is. Field of new aggregate. Second one says and field of BWA indexes. BWA is a separate BWA for performance, but not every company has that because it's another tool they have to buy. Okay, it's just like HANA. But obviously HANA is way more than that. But companies still SAP, but it comes with a separate license. They have to purchase that for enhance performance. So when you have BWA, you can use this to, fill the index. Roll-up field aggregates or BWA. How would I use? You can use this, the third one, or you can use the first one. It really doesn't matter. Okay, so this process type, if you pull it in, create a variant, and then you can define, whatever name or the InfoCube name or whatever it is. You can define it over here. Okay, so that's how to inculcate this process type, automate the roll-up process for you. Okay, a very important aspect of aggregates I want you to pay attention to here is, when do you determine when to create aggregates or when it's necessary to create an aggregate? Okay, that you have to consider that. Okay, and let's go back to the PDF and review that. So the guide are these. Yeah, and from the PowerPoint point, you see that I said considerations in building an aggregate, and these are all tips. Relatively smaller aggregates compared to the, it makes sense to define your aggregate with all the dimensions. And the aggregate is as big, it's not for cube. So really, you've just created two separate places in keeping the same data. It's really going to degrade the total system performance. Meanwhile, you're not really at performance. Okay, your response time is not going to increase if you have then there's no point. So that is the first one. Always make sure that they are relatively smaller. Point is summarization or higher, and I'll show you exactly what that means. Summarization ratio should be 10 or higher. Third point says that find frequently accessed objects to use for the aggregates. And what that means is that whatever parameters your queries have been created on, those are very good candidates to create your aggregates on, to define your aggregates with. If in your query you're using material a lot, you're using month a lot, you're using sales rep a lot, whatever, make sure that you correctly define, or you use those objects to define your aggregates. The fourth point says that frequently used queries should be good candidates for aggregates. Okay, so aggregates are not created in vacuum. Aggregates are query response time. It just makes sense to know which query you want to enhance the response time with to create an aggregate. So just like I said, when you think of aggregates, think of an InfoCube. Likewise, when you think of aggregates, think of queries, because they all go hand in hand. Okay, if you have a query and you do not use that query very much or very often, or let's say you only run that query once a year, it doesn't make sense to create an aggregate on that at all. It really does not make sense to create. System needs to allocate resources to maintain that. Would also all totally affects everything, the ripple effect that I've been talking about. So if queries are not being frequently used, why do you want to enhance them? The don'ts. It's too big InfoCube aggregate relationship. And I think that is what we talked about. Okay, aggregate should be really lesser, and it should be a subset for an InfoCube. It shouldn't be this. Two similarly several aggregates. So Can and Ikea or Ade and Free have separate queries there? And even using customer, very often in the report, however way they want to view the queries, they use material. They want to see the material view of things. So they're using material very much. And Ken has already created an aggregate on that cube and define material in his aggregate. And then Free goes to define another aggregate again, using the same thing. That Ken has already created one already. Once your query runs on the same material aggregates, and you define a cube, when both queries are running, it will know it would make your response time faster for you. So two similarly several aggregates should not, it's not good. Don't do that. Okay, frequently used aggregates. If you define an aggregate on sales rep and you barely ever even have sales rep in any of your queries, chances are that aggregate will not be used at all. Because the only time an aggregate is used is when that object is defined in the query. If that object is not defined in a query, do not define an aggregate for it. It's just occupying space for nothing. It will never be used. Do that. Because at the end of the day, you're creating a system, you need system resource to be allocated to that. Or it actually consumes space, storage space. And you don't, why consume space when you're not using that? It doesn't make sense. So these are the do's and don'ts as far as aggregates are concerned. Okay, now what I want to focus on is the point 2 for the do's. So point 2 says that summarization ratio should be higher. And so in the system, and these are good points. Again, I'm going to add another point that Evans did not put over here. So I'm going to do another 5th point. Or let me just explain. So sometimes for you to determine when to create an aggregate on a query, it depends on the response time. Okay, so how do you know how much time it's taking and whether that time it's realistic or it's not? So there's a way in determining that. Let's ST03. So when it comes to transaction ST03, okay, and today. And this is another place you can come to see, to see how certain things are performing. Your data. It's another place for performance monitoring. Okay, and it's right within DW. It's nothing you have to do. It just enables you to have statistics of what is going on in your system. So over here, is this a disk cube? Let's see. This is Adewale's Q26. What anything for today for Adewale's Q. Let's see. ZAG underscore IC2. This is Anna's Q. Okay, great. So over here you can see some kind of statistical information as far as performance is concerned on this. Okay, so it's saying that the number of queries on this, it gives you the total number of queries on that queue. It is 1. The number of navigation is 3. time, and this is where I want you guys to pay attention. Total run time, and I think it's in seconds. Yes, it's in seconds. It's 3.4 percentage of the all-up time. So what it means is that percentage of all-up time means that if you put your cursor on it, says that database runtime divided by the total runtime. Okay, so let's say that right, and then the report took 5 minutes. But out of that 5 minutes, 4 minutes of that total 5 minutes was spent on the database itself, retrieving the data on the database itself, spent on, you know, the presentation. So after it retrieved the data, it took extra minute to present it. Okay, so there is a ratio. So if you have like the time spent on the database, substantial part of the whole query runtime. If the time spent on the database is less than the whole period time, the whole run, you know, then that means that your queries are not, you literally have to do. The problem is, you know, it's with the response time as far as the presentation wise. I don't know if what I'm saying makes sense, but let me take it again. So let's say that, let's say I have data in my house. Okay, my house is the database, it contains data. And I need to fetch that data in my house and put it in my garage, from my bedroom to my garage. Okay, so your garage is your database. In getting the data, total time in getting the data from your bedroom into the garage is 10 minutes. But out of this 10 minutes, 2 minutes was used to retrieve the whole data from the bedroom. Okay, so the bedroom access time was 2 minutes. And the remaining 8 minutes was for presenting the data. So you've already retrieved the data. Walking from your bedroom to the garage took 8 minutes. That is totally unacceptable. That means that your queries are not running well. It's a very, if you have that kind of statistical information, then that means that that query is to build aggregates on. Okay, so let me flip it around. Let's say that the total time it took you to actually get the minutes, and then it just took you 1 minute to, you know, populate the garage or walk from your bedroom into the garage. That query is doing well. That means that the only thing that needs to be done should be at the database level. And chances are you will not do that. You may do that or you may not do. It totally depends. Okay, so good candidates. So right now we are talking about good candidates or good pointers to define an aggregate, or what should the criteria be? What should the basis of you defining an aggregate on an info cube? We've already talked about the fact that whatever objects are most frequently reported on, you need to define an aggregate on that. What else should be the driving force in creating an aggregate on a cube? If the time it takes you to present the data is more than the time in the total runtime, then it's a very good candidate for that. So how do you tell? So over here you see the all-up time. All-up time. All-up time says the all-up time divided by total runtime. And total runtime is from the bedroom to the garage. That is total. Okay, so out of this total time, you have 26.7. All-up time is 23.5. Over here, I'm looking at the top one. All-up time is 23.5. Base time is 2.3. Clearly tells me that this is total. So let's take a look at this queue. So this queue, the total runtime is 3.4. Out of this 3.4, the database time actually was 0, and the presentation time was 2.9. So that the presentation time was a good portion of the total runtime. So this is a good candidate for IPA. Okay, and I'm gonna let me copy this link right now and then email it so that we can go through it, because I have a very good document here that would actually clarify things more. So one second out right now. Eva underscore Myers and can you guys hear me? Can you guys hear me? Hello?
Yes, yes.
Okay, great. All right. I'm trying. It's taken forever. Let's see what I can do. Okay. So let me find over here. Can you guys see my screen? And I'm going to forward this to you guys so you get this as well. Can you guys see my screen?
Yes.
Okay. Post the link right here for all of you. So this is a very performance. You can save it on your desktops when you get a chance. So quickly, let's just run through aggregates. Aggregates say that materialization of aggregated subsets of InfoCube fact table data. We've already been through this, so you can read this for extra information. Okay, so remember what I said. It says that aggregates can improve query performance considerably. It also impacts the load performance. Okay, so you want to make sure that you only define aggregates only when necessary.
Eva, so can
Yes,
you
sir.
say that we will really typically create aggregates on frequently used queries or rather InfoCubes that are queried a lot? In the real world, can you say we only create aggregates for those cubes?
What I would rather say is create aggregates, define aggregates for frequently used queries. Used objects. So when you say that, then the cube will also come into the picture, because you know that, whatever your reports are on, they are definitely being fed from the cube. If your reports are being fed directly on the DS, so then aggregates will not even, right, we've already touched that. Aggregates are specific for cubes. But if I flip it, I would not say the reverse will be true or the reverse is necessary. So lots of aggregates on. I would not say that for sure create aggregates on that cube. Because what is going to be your driving, what is going to be your determining, what objects are you going to define the queries on? Or how do you even know that the queries are just fine the way they are? Okay, so I would rather say that, and there are so many pointers. That is what we are going through. One of the determining things is look at the query first, and then depending on the mean value and all those ratio numbers, define an aggregate for the query. So whether you build an aggregate on a cube or not, the goal is that it has to be defined with a query in mind. So did that answer your question? All right, no.
You did. But would it be better to create smaller cubes or no?
Smaller cubes, yes. And we will talk about that when we get to multi-providers. Smaller cubes, but smaller cubes are definitely right. And the reason we create smaller cubes so we can get data into one cube, like the whole set of data into different groups of cubes, and still have aggregates on even those smaller cubes. Because aggregates definitely should be a subset. If you're creating an aggregate, it doesn't matter how small your cube is, you can get it even smaller with an aggregate if you need to. Okay, but in real life, nobody will just load material. You remember how I was showing you this? We're looking at this diagram. In real life, nobody will create a cube and just have month and revenue in the cube. It doesn't make sense. You're not making the optimal use of the cube. Because why you're creating a cube? Because you want that is in the data source into the cube, or majority of the data into the cube. Because the cube will not just be one query. You should have a cube that can have different queries on it. Right? So only use aggregates to define that smaller set of data you want to see and not just the cube. Because if you want to have, let's say you have this cube, right? It has month, material, and revenue. And you choose to group this cube into smaller cubes. You have month and revenue, and you have another cube called material and revenue. Okay? Versus having one cube that has month, material, revenue, and then having an aggregate on them. Having two aggregates on one cube. Which of these designs will be better as far as system performance? One cube, two aggregates will be better than splitting these cubes into two cubes. Because cube takes. Does that make sense? You would not want to have basic cubes like that. You know, if you want to partition cubes, it just makes sense to put, let's say you have 20 years of data. You can choose to put 5 years in each cube. That is what makes sense. But as far as the all cubes, to do better, or an aggregate will, will be the optimal use of that. Did I answer your question?
Yes, thank you.
Okay, so let's go back to our slide over here. And then this is the tip. So the tips over here says that it says do the following tips for creating aggregates. It says call query or info cube overview in technical content or ST03, and that was what we went to. Sort by mean overall time to find queries / info cubes with highest run times. Okay, so you want to sort any cube or queries that have the highest run times. So over here, and this is just a guideline. You can choose to do, once you grow, you will understand this better and you can choose to do whatever you want. Okay, so all it's saying that if you want to identify cubes for, cubes or queries for better, as better, you want to identify the good sorts by the highest mean time. Okay, so for instance, you know that all these 19.4, but it doesn't mean that it may be a good candidate for aggregates, okay, depending on what goes on. So let's see over here. It says that sort by mean overall time to find queries with highest run times. And then it says calculate the ratio. So the aggregate ratio is calculated, and that is an indicator, when to create an aggregate or not. So it says that calculate a KPI for aggregation ratio. It says that number of records base divided by the number of records transferred. Number of data read. Okay, so number of records should be, let me check. RSDD started. Here. Okay. Ratio is equal to number of records read from the database. And then it says that check is time to total runtime of that. And then the rule of thumb says that an aggregate is real and may be created if you've done your calculation, if the aggregation ratio is greater than 10. If it's greater than 10, that what it means is that it takes more records to read than is displayed. I don't know if that makes sense, but let me take it again. So if aggregation ratio is greater than 10, that is to say 10 times more records are read than are displayed. So if, you know, like I was from your bedroom to your garage, okay, your bedroom, the total time in getting the data from your bedroom to the garage was 10 minutes. And it took you 8 minutes to retrieve the data from your bedroom, and it only took you 1 minute to present it or to put it into the garage. It took more time to access the database, and that could be a number of reasons, right? That can be so many. It could be that, you know, it took performance, you fetched too much data than you presented. Okay, so the aspect this is explaining is that 10 times more records were read. So you read more than you needed to present. So why not create an aggregate on that so that the aggregate will just read exactly what you want to see? That is all this is saying. So ratio greater than 10, it is a good aggregate. Okay, because whatever you define the aggregate is what will be read, exactly what will be read, and not what you don't need. And then the second pointer says that the percentage of database time should be greater than 30%. So what is saying that, you know, a good part of the whole time spent on the database, it is better. So percentage of the database time should be 30%, should be greater than 30%. That is, the time spent on database is a substantial part of the whole query. Okay, so if the time spent is actually between the presentation layer, then your queries are really not doing well. All right. So how do you determine this? This over here gives statistical information as far as, you know, how your cubes or your queries information, and this is in the system, it's in the BW system. There are other statistical reports that you can also do something like this. So you would hear a lot about BI statistics when you start working. BI statistics are nothing than standard reports. They are business content delivered reports. Okay, so you load everything that goes on in the system. So if you think that you can just do anything in the system and nobody will know, let's say you go delete somebody's data, or you go delete something and you think nobody can tell, yes, system tracks what they can tell. They are called statistics. Okay, so there are some reports that can tell, reports that are, you know, queries that are most often run, frequently used reports, frequently used this, you know, they give all those statistical information. You can run that report and it will give you an idea. Let me go here, let's see what we have over here. And average times will also give you more information over here. Let's see, all data can also give you more information over here. This is a database records. Database time per selected records. So back to the here, how ratio. So let me put over here the percentage time. So in your PowerPoint, you have over here that summarization ratio should be 10 or higher. This is what it's talking about, the aggregation ratio. They are the same thing. It should be 10 or greater. Okay, if it is a good candidate for aggregate. So let's see exactly how they calculated the aggregation ratio. So this is a report they run, like reports in the system. Okay, so they run, and so this report will give you the mean overall time and the total that were selected. Okay, so what they did over here was they ran that report by mean overall time to find InfoQ the highest run times. So they sorted by the highest run time. And then over here you realize it says the database time. And then we all saw that it should be greater than 30%. So if it's 40%, that means that it is greater than 30%, right? So it's a good candidate. How do you determine that it's greater than 30%? So this was the calculation. It was 40% of total runtime. Total runtime is 6771, which is this. The time reading database was 6771,404. And it was 17027. So the overall time was the database time was that. And then the records that were selected was 29.990.489. That was the records, total records that were selected. Transferred 12050,721. So the ratio is total selected divided by the total transferred, and it gives 24. And 24 is greater than 10%. So that it is a good candidate to create an aggregate. If you create an aggregate on this, it will improve performance. Because why select this number of records over billion records and only present 12 million? Over they only present 12 million. It doesn't make sense. Okay, so that means that you have to create an aggregate so that it will read exactly what needs to be transferred or something close to that. So you realize that it says over here that the aggregates will, if you create an aggregate on this scenario, will definitely improve query performance. Okay, if we scroll down, let's see when an aggregate will not make any difference. So over here, aggregates will not improve query performance if the database time is 3.5% of total runtime. We know it has to be 5. So if it is 3.5 and the ratio is 32, ratio should be 10 or more. So even though the ratio says 32 over here, the database time itself is 3.5. It's less than the 35% we said. So even though one of them fits the criteria, creating an aggregate will still not improve performance. Okay, that is what it says over here. The reason being that database time, so of the total runtime was 10 of 28,540. Time was this, and then the time reading the database itself was this. Okay, that is bad. We've seen that. What selected was this, and then the total transferred was 161. So it made the ratio higher. Okay, it doesn't mean that it will improve. It's more, and the database time itself is 3.5, approximately 3.5. It says that aggregates will not improve query performance. And then we'll explain further down. So let's read on and see. And then over here, the flip side is also true. It says that if the database time is 90%, and then the ratio is less than 10, will still not improve. But it doesn't mean that you have to follow them strictly, because I really do not agree with some of them, but they are just pointers. At the end of the day, it totally depends on your system, your queries, and what is happening in your system at the end of the day. But just understand that these are check marks. The thing is, you have to understand that when you have to define an aggregate on the objects that are in the query. Okay, and if it takes more time to present the data versus retrieving it from the database, then it's not good. You have to create an aggregate for that. Okay, those are solid marks, but everything else are just checkpoints for you. So over here, so it's saying then highest contributor in total runtime per info queue is the high database read. So instead, the total time is 73.9, and then the database read time was 30. That is okay. So it's just saying the same thing over and over again. Okay, so it's saying that over here, when they are both, they all fall within the criteria, 60% and 54%, then aggregates will improve performance. Okay, so you have this link. Just go and read a lot on that. And when we come back again, so after today's official end of the class, I will give you some time to just get everything together, go over all the videos, read everything, and then we may converge again for assignments and projects to get you ready. So that brings us to the end of the second point, aggregates. Any questions on aggregates? Any questions on aggregates before I go to the next point? Okay, if there are no questions on aggregate, next point is compression. What is compression? Compression is another performance query, and all the points we're talking right now are related to the query side of things. Okay, so compression is for queries. And again, compression is only done on info cubes. It is not done on DSOs or in so too. Okay, and what is compression? That getting rid or nullifying your request IDs, aggregating data together. So let's see over here. If I go back to Adewale, what happened to Adewale's queue? Yes, this one right here. Two requests, right? What this means is that data is partitioned. So if you wanted to just view data for just this request, this 15330, you can just view the data that came in this request. And you can do the same for that. Everything, you can view everything too. But what happens when you're running queries on an info queue? And is the owner processor. So the owner processor is think of it as the engine. okay, that, or your servant to take, to retrieve the data. So that is what processes the data, actually. So what it does is, during the query runtime, it would come into the queue, okay, and then it would go through it would do a full table scan. And what that means is that it has to go through all the request IDs. So if you have, right now we only have, but in real life, every day when you load data, it brings in a new request ID. It brings a new request ID. So over time, you have request IDs growing in your queue. So you can have a number of request IDs. When your queries are being processed, will have to come in here and go through all, and then before it can actually data for you and present it in the report. Okay, but if you do compression, what happens is that in the background it nullifies the request ID. So data is no longer partitioned by request IDs anymore. Data is just, it aggregates all the data together and it nullifies the request IDs. Because if it does not nullify the request IDs, that means that the data will still be in the individual request IDs. But it nullifies that and it aggregates the data for you. It's saying that, hey, I don't care for the partitioning. I don't care for the separation of data. They're with the same key to aggregate together. Okay. So when that happens, data moves from the F-fact table into the E-fact table. So that is what happens during compression. Data aggregates together to have the same key. And the data moves from your F-fact table to the E-fact table. And your request IDs also get, it means that in the cube you will not, they will show them, it will still show. But in the background they are no longer effective. They no longer, okay. The downside, anytime you do compression, you will not be able to retrieve your data per request IDs anymore. So let's say that you compress this data, these two requests, right? You made them into one. And now you're interested in just analyzing this request, 15330. Let's say you realize that the data was wrong, so you want to delete this data. If you do compression, you will not be able to do that anymore because in the background, data is no longer separated into two requests anymore. It's one, and it's been aggregated. So you cannot just know which data ties to this request. You can't have that definition anymore. So before you compress data, you want to make sure that data is right. You will not need to analyze data or delete data per request anymore, because you will not be able to do that if you compress. Okay, so let's go to our PowerPoint slide again. So this is what happens exactly during compression. And this is your F-fact table. So in your cube, in the real cube, before fact table, okay, it's all F-fact table. It's one fact table, which is the F. And you have data partitioned into these for you. So you have to go through each and every one of them. Press. So this is request one. Request has material number 1. It has January 2011 and it has amount. Request 2 has the same material and it has a different amount for you. So what happens when you compress is that if it looks at the same key, so over here the key will be, let's say, material 1. So it will put in your E-fact table material 1, January 2011, and then the total is 140. So it's aggregated the data for you. So right now in the IFAC table, you don't have request individual. So if you're going to have request ID, which request ID is it going to take? You have you or me anymore. It's one. It's just like husband and wife. You become one. They are not two individuals anymore. That is why they are inseparable. Okay, so over here, request IDs do not come into the picture anymore. It's just one data. So if the query owner processor has to retrieve data from here, from the table, it will be much faster because the table will just be just one line. Over here, it needs to go through all the request IDs before it would aggregate them together. So compression also reduces query runtime. It's much faster. Okay, how do you do compression? It's as simple as just choosing the request ID you want to come over to the collapse tab. And it's very important to do collapse. You come to collapse. Okay, the request ID and click over here and do release. Once you do that and you come over here, you see that you see this clock over here. When you refresh, it will turn to green. And you realize that it does the green check mark and the compression status for you. So if you compress and you do not see this correct sign, the compression was not successful. Okay, if you see this, that means this is an indication that your cube is being compressed. And you realize that you still show the request ID. They are not, they've been nullified. So data is no longer partitioned by request IDs anymore. It's just one. So this I've done right now. If I request ID, I will not be able to delete it. Highlight and I do delete. Do you see what it says? It says that request ID this is aggregated, compressed, or scheduled. So I cannot delete it. So if this data is wrong, you are screwed up. You can't delete it. You've compressed it. You're only to clear the entire data. So can you imagine you have 20 since 20 years back, and you loaded something today, and you compressed it, so it went to aggregate to all the 20 years of data. Before you realize that you had not loaded, data was not right, data did not come in right, you didn't do data validation, you didn't do enough compressed. You are so screwed up. You will not be able to delete this request anymore. You can't do it. Your only other option, selective deletion. And what selective deletion is it will just objects. Okay, you cannot delete the entire, because the entire request has a number of objects in them. It's a whole bunch of data. You'll not be able to delete them. But if you want to delete like individual objects, you can use selective deletion. How do you do the selective deletion? This tab over here. And then in here, you can delete. Where is the selective deletion cell over here? Is it content? It's rather content. You come over to content, and then you do delete selection. This box over here, delete selection, and over here you can choose what you want to delete. So you do delete selections, and then if it's customer ID, you want to delete. If it's a clear, you want to delete. You can't come right, and it's ID. You can specify and just delete it. Execute it, and it will delete that. Okay, so when you specify it, you hit start, and then it will delete it. This is your next best option in deleting, but that will not delete the entire request for you. That data that came in a request, you will not be able to do that after compression. So rule of thumb is, before you do compression, Make sure data is right, you have validated data, and there will not be need to delete data per request anymore before you compress. So realistically, compression in your process chain, or you want to compress, ideally we compress data after 2 weeks, after every month. Allow yourself ample time to validate data before you compress. You don't want to compress every single time you load. So every day you're compressing, every day you're compressing it. It's not good practice, because every day you may not have time to have validated data very well. Okay, so have that in mind before you do compression. And performance tuning, for sure will come in your interviews. So this is another to get hands down, get very, very well. Okay. So this is all there is to compression. I'm gonna delete the data in the entire queue and then push data again and then see what we be able to delete data before compression, so you can see the difference. Okay, I'm gonna go ahead and push it again. Alright, so right now we haven't compressed it. And let's say that we just realized that the first request has erroneous data, something we're not supposed to load. You want to delete it. It's as simple as just highlighting it and just do delete. And you realize that there is no mark over here under the compression column. Over here, we don't have the check mark. That means that the data is still partitioned to request IDs. Okay, so if you want to delete one request, you can delete that. And there you go. It will delete. It's deleted. It didn't complain. But immediately you compress it, you will not be able to delete it. How do you automate compression process chain? It's also another process type. So that is a typical process. A typical process chain will have that. Okay, you can just set it to compress every 2 weeks. So again, if I take counts, and when we are done, we'll come back and feed all these in one process chain. So over here, you do for queue. You can create a variant for it and use your info cube. So let's say this was queue, current info queue. You put it over here, and in here is when you specify. So you want to say that collapse only those requests that were loaded, blah blah. So days ago, you can put it over here, which is 2 weeks ago. You can put it over here. So only the older, any data that is, any request that is older than 30 days is what you want compressed. You can define all those settings over here. Okay. And over here, if you want to specify the number of requests that you do not want to collapse, meaning that you don't, over here. These are specific to inventory. Inventory has a different way of compressing data. And this will come in your project. You don't need to know that for now. Yeah, but this is how to create a variant for compression, and then you can pull it in here, and then you can automate Okay, so any questions on compression? So compression reduces by combining records with the same key. Okay, understand that records are only combined with the same key. Friend requests. So if this request 2 did not have material 1 and it had material 2, it will not be able to aggregate because they are not the same. Any questions on compression before I move on? Okay, if there are no questions, the next performance technique is all-up cache. What is all-up cache? All-up cache is nothing. When you think of cache, think of memory. Okay, cache is. So that is why sometimes when you visit some websites on your computer, it stores it in memory for you. So next time when you're going there, you realize that immediately you type the first letter, it populates it for you. So in BW as well, as part of query performance technique, you can pre-calculate your data, or you can actually data in memory for you, so that when the query is being run, it will not have to hit the database to access it. Okay, so in memory, somewhere in memory, you just keep data there to be retrieved. It will not have to go into the underlying table. And those of you that do YouTube a lot, you realize that sometimes when you're playing YouTube videos, it takes long, for the thing to run. The reason first time is now accessing the main port, the main place where the video is. But you finish watching the video, it's already stored it in memory for you. So you can easily, when you go back and you play, it will not take as much time as initially. It will be much faster. It's pre-calculated. It's already stored it in memory for you. How do you do that? This is the T code in doing that. And this T code it takes you to the query monitor. Okay, you can do so many things over this. So let's go there. Let's see how it looks like. So over here, you can do so many things. You can, change your queries. You can choose a query, and then you can, define its cache or whatever, or view what it is. I want to choose this query. I want to see performance info, any information. You can do performance info, and then you can review the status of it. So it says a database statistics check, RSRV check is necessary. So it's telling you to check RSRV. I remember RSRV was, we're looking at the dimension factorable ratio. Okay, so you can do that. You can check the info and technical information. Information will give you so many information so that you know read mode. It gives you the read mode. The read mode says that it's been fixed on read during navigation or hierarchy drill down. We'll go there. You understand what that is? Before navigation, no, it gives you information. Or if you do cache monitor the sizes. Local cache. So global cache, what global cache will do is that it will calculate certain things in memory for you globally. Something is being queried on, it's already calculated it for you. It will not be specific to, it's global. to wherever it's being used. Okay, so and just play around. You can even generate a report. You can do execute, generate a report, and just over here and just see what they all do. Okay, see how set your query property. So you put in your query name and then you come over here to properties. And then over here you can mode. How do you want cache mode or your read mode? However way you want your data to be read. Okay, so in here and over here you can do F1 on them, and F1, I don't know why F1 is not on my computer, but I should do it on your computer. And read on all these different read modes. Okay, so set it. So the A says that to read all data at once. The X says that query to read data during navigation. H says that or expand hierarchies. So what are the differences? When you set it, what it means is that you want to pre-calculate all your result sets in memory. So whether you will use it or not, it's already stored it for you. It already stored for you. Is it good for performance? No. Because it would take time to read everything at once. So it's because if you don't need it, it's just gonna pull it for you. It sounds like it's good, but it's actually not good. The best thing you wanna do is only when you're navigating. So you want the query to read the data from memory only when you're navigating to that. And if you have hierarchy, so you want to choose this, so you can choose that. But I think by default, let me go back to this. So by default, it's set to query to read when you navigate or expand hierarchies. Leave it at default. Default speak for you. Default is best. But yeah, it's also good to understand what they do so you know which one to use or not. That you cannot use this. You can use this to read at once. It's you, yes. But you have to understand that what it does is you need it or not. And that can take time. Do F1 or F4 and they'll give you more information and you can read more on them. Next thing is cache mode. And you can leave everything as it is over here and you will be okay. But what is cache mode? There is cache inactive. That means that you don't want to cache anything. You don't want to pre-calculate anything in memory. You don't want to store anything in memory. Okay. So, and if you do main memory cache without swapping or cluster added, whichever way, it stores it for. If you leave it in memory, if you leave it at default, default says that without will pre-calculate for you, it stores it in memory for you. And then if you check this mark, it means that update. If you want the delta to be cached, you can check that. It's default. By default, it's checked. I will leave. Okay, and this is a text specific. So we're not even gonna talk about that. Another place I want you to pay attention to. Query optimization with individual periods and days. Query optimization inactive. If you don't want to optimize it, you can choose inactive. But here again, if you leave it at default, you're good. The statistic determinant. So you can choose anything available for you. And then it's a my system will see the differences. But this looks like, I think it's actually better. Okay, so over here, leave everything at default. If you want to do more reading on that, you can do F1 and it will give you more information on that. So if you want to execute this, you can execute it. Whatever parameter you want to give it, whatever calendar year you want to read on, you can run it. So many things over here. And over here, if we go to our, it's also another place. Is cash. Okay, over here too, you can do, you check your buffer monitor. Technical, if you're not very technical person, don't want too much technical detail to worry about this. But the basic performance are, the main things you really need are what we are talking about. Just over here, really, just set your properties, to read when navigating, and you're good to go. If you want to check more information on how your query is doing, you want to if you want to check on OLAP processor, you can do the cache breakpoints. For data manager, you want to do multi-provider explain. RRI transformation in this report interface. And you want to check data from virtual info provider, whatever you want to debug, you can debug that.
Eva?
Yes.
Processor. Where is these or is about the data loading? Is in BW or where it is basically?
Everything we are talking about is query response time. It's to queries. It's not data loading, and it's all in BW. Whether it's all specific to be, but performance is grouped into two main areas: query performance or load point. And what the two mean is nothing but how quickly your query. That is all there is to query performance. So any technique you do, the end result is that it has to make open faster. So that when you're opening you go to query your report, it will not take 20 minutes. For something that can take. And all the techniques we've said, you realize that sometimes if you don't even compress your cube and you're running the report off that cube, it can take 5 minutes to open. But immediately you compress, you realize that it will take 2 seconds. It happens on the job a lot. 2 seconds is totally unacceptable. Users will now wait 5 minutes for reports. But if you don't know that, by simply compressing your data in your queue, you can reduce your response time from 5 minutes to 2 seconds. Then you will not know, right? So all is compression, RSRT properties, and aggregates, and everything we've talked about today is specific to how quickly your queries open. We haven't touched on data loads at all today. I'll come to data load performance when I'm done with the query performance. So can that answer your question?
No, it's still confusing about OLAP processor, where it is,
Okay. And other cards are totally different. As the servants that you can just send around to go retrieve the data for you. So anytime there is something, an engine in the background that goes and fetches the data, it communicates. Data is not stored in your queries, right? All data. They always access the underlying info provider. That is the OLAP processor. And the reason it's called OLAP is a processor. OLAP is simply because it's more analytical. It's on the query side. It's all an analytical processor. That is the data for you. And that is all there is to it. OLAP cache. And the reason that using online analytical. It is not OLTP. It is OLAP. It is done at the BW side. Cache is simply pre-calculating your result set in you. So OLAP cache, OLAP processor, they are two separate things. Cache is a technique, performance technique. OLAP processor is just the tool. It's just the engine that gets your data for you. For it, from the underlying info provider. Does that sound right?
Yeah, yes, thanks.
Okay. Any questions, guys? And I'm going to give you some things to read on another material to you guys right now. Compose. And I'm sending you all these materials. Read, and read. Read a whole lot on performance. Because performance, definitely. Definitely. Let me paste it for you guys. Right here. And really, you don't need to read this. This is just for extra info, especially the main points that are necessary. You find a lot more information here that is just good for personal knowledge, but you need that to get a job. No, you don't. It depends on if you're in a curious type, you can read. That you can just do the videos and you will be fine as well. So, Karen, let me read what OLAP processor is for you again. Right here it says OLAP processor. It says to access data stored in SAP BW, the end user to know which database tables store the key figures and characteristics. They don't care. They don't even know. Okay, no specific aggregates in a query. To the changed status of the data in an info queue. Data access does not occur directly on the data stored in the database. Instead, data is accessed with the online analytical processor. Okay, so that is the only way, that is the end and present it to your queries. So the other processor is a query management tool that translates the query defined by the end user into a language specific to the database Then it returns the data stored in the info providers to the front end in a multi-dimensional and formatted view. Okay, so that clarifies everything. It's just the servant, the middle person that goes to retrieve the data for you. Okay, so you have the link. You can read more on that. Any questions on compression or cache? Okay, the performance technique. Okay, who can tell me what indices are? People a lot. I'm not going to make it too complex for you with, but let's see what you guys can tell me first on indices. Just look at the slide on here. I'm sure it's pretty much self-explanatory. And tell me what you think indices are, and let's quickly do this. Anybody wants to try? What do they do and what are they?
I think you might have explained it in one class before. I think you said that indexes are used on database tables, look at data faster, and I think you had an example of a book and its pages, indexes.
Nice, so I already talked about that, yes. So that is all really there is to it. You know, I mean, index numbers, right? If you have so many students, and if I assign index numbers to all of you, it will be easier to, you know, retrieve student information. So if today, you know, I have 2 at this, and they all spell their, let's say they all spell their name at day in class, and they don't have index numbers. I haven't assigned index numbers, and they both want their transcripts. I probably have to look through the entire database to find all their days before I would even figure out which transcript to give to the right person. It will be easier to just pull your information, and it's as easy as that. The same thing applies. Have indexes on them. You know, for instance, this, they have indexes. If I'm only interested in reading on overview of SAP BW architecture, index is to go to 3.2, or the page number is to go to 3.8. So I can just type that directly, and it will take me straight away with them. But if I didn't have any numbers, any kind of indexes, so indexes are nothing but numbers that are specific objects. Okay, so in structure in this book, can you imagine? And I have like over 20,000 pages. I have to flip through all the pages or read through everything, do a whole book scan through the whole book to what I'm interested in. Okay, so thank God for indexes. Okay, so that is all there is to indexes. When you have indexes, you create indices that are faster. Okay, and usually your keys will be your, you can create secondary indexes. You know how you have subgroups, like you have 2, right? And then you have 2.1, 2.2, further grouping. You can create secondary indices to even help retrieve data. Okay, so that's all it does. Full scan of data. But if their indices, if document number 9999, or for this whole line is 9998. You know, it's to retrieve that data. You know, and you don't do that. You don't go calling the index now, the indices. This whole thing, so it knows. Anytime you have customer number in a query, it knows the underlying index to it. So it just retrieves it faster. Okay, so all you have to do is just define indices, or the software will intelligently take care of the retrieval. So let's leave this as simple as it is. Questions on indices. And you can automate this process in the process chain too. Okay, so a typical process chain will have, and then it will be deleted before loading data, and then it will be recreated after loading data. The reason there, it makes your loads take longer to run. It impacts your load performance. Even though it's better, it makes your data retrieval, you know, to the queries better in parts, because then that has to be loaded, right? It's another space that has to be filled, so it's much faster. So you want to just assign them after you have loaded the data. We'll fix them in the process type. How do you do that? Let me quickly show you. It's also another process type. Delete index, generate index. These are what you use to do it. So you typically delete it before you load, and then you generate after you've done your loads, and you're done. Okay, so let's see what next. What is the next query performance? The next thing is what we're going to call partitioning. Okay, I'm going to treat partitioning together. It comes under two main headings. We have what we call logical partitioning and what we call physical partitioning. The physical data partitioning. It's just like your computer, how you have your hard drive partitioned into different drives. You have your F drive, your E drive, and all that, your C drive and all that. It's apply the same logic, you know. So it physically partitions the underlying database. Your info cube, right? The main underlying database will be partitioned if you do physical, your fact table for you. And there is only one info you can partition by. It is either by fiscal year period or 0 calendar month. It has to be a year month thing. You cannot use local day or anything. This is the only characteristics that we use to do physical partitioning. It's either fiscal year period or calendar month. Year and a month format. Okay, and that's really all there is to physical partitioning. Physical partitioning, you will not find that very much on the job. It's actually old. It's been outphased. Okay, I want to focus my energy on logical partitioning. What is logical partitioning? Logical partitioning is just logically data that logically relate together into separate info providers. Okay, so that you can have a multi-provider on top of them for parallel pool. Why do we do logical enhance performance? How does it enhance performance? Let's take, for instance, you have one cube. And you see how we have cubes over here? You have NA cube, SA cube, you have Asia, and you have Europe cube. Can you imagine that you have all these 4 cubes, the data in all these 4 cubes? So all these 4 cubes have data that pertain to each area. So Europe cube will only have Europe data. Asia data. SA cube only have SA data, and NA will also only have NA data. A company you have, like Walmart. Walmart is it's in Europe, it's everywhere. It's in North Africa or North America. It's everywhere. Okay, but you only have that manages all of them. Okay, and you just want to load data that pertains to all these regional areas into different cubes versus getting all of them into one cube. The difference between loading the data into different cubes versus having all of them in one cube is that if each of these areas have, let's say, 25, okay, so each of these will have 25 million. If you put all of them in one cube, you're going to have 100 million. 100 million records in one cube. If query is pulling data out, it will take forever because it has to do a full table, go through all of the data before you can get your data. And it's even a much bigger data to search through versus having, okay. So what you would do is you want all the data. You want a report of Europe, Asia, South America, North America in one report. You can still have a multi-provider on all of these cubes, and then you can pull them together, pull the data at the same time. And guess what? Even though you're having access to all the data, it will still be 25 million records that will be searched instantly at the same time. And it will be faster versus having just one cube with 100 million records. Okay, I need confusions. I know I left you guys to ask me questions. This makes sense or it doesn't. Would you rather put all the 4 things into one cube and report versus splitting them up for? What do you guys think? Do you guys need a break? To break and come back in 10 minutes? Should flow.
Yeah, we're just listening. Okay, good.
You're just listening. Okay, so does it make sense to logical cubes? It doesn't make sense that it will be faster as far as your query response time versus having them in one cube. Does it make sense or it doesn't?
Yeah, sure.
Why do you think that was one cube? I mean, if it's just one cube, it's just one place to go to, right? So why the logical partitioning be faster?
Because when you write the query, it's any specific cube you have. Say, for example, say manager in North America, they want to see the information about North America, so they don't need to go, all other cubes. So they can only write the queries for the North America, and they can get access information about it.
Okay, that makes sense, but that is one side of it. So my question is, assuming you want data for all the 4, you want North America, you want South America, you want Asia, and you want the data, right? You want to find, you want information on all these areas in your report. Okay, person chose to put all of them in one queue, to split them up into separate regions. Which of these 2 designs do you think would be better as far as your query response time is concerned?
Eva, are we retrieving data from all four? That's the scenario?
You want all the data from the 4.
Okay.
Okay. You want
Can you?
Yes, so that's what I'm saying. So you have one cube, it has a multi-provider on it, and it also has a multi-provider. Okay, so whether one cube with all the data in one cube or the data split into 4 different cubes, they both have multi-providers on top of them. So which of these 2 multi-providers will make your queries respond faster?
The one that has them separately.
Okay, why?
Because if you're retrieving data Asia, the analogy you used before, it's cluttered, and you're finding an item, it might be more difficult to get that item, amongst all them. You have the fewer items you have in that particular room, you finding out the data.
Okay, that makes sense, but you're leaving the other part I was talking about. So let's say that you just don't want one aspect. You want everything. So let's say that North America has 20, South America has 25, Asia has, and you want all this data. You want all the 25 from North America, all the 25 from South, all the 25 from Asia, all the 25 from Europe. You want all the data. You want all the 100 million. And you guys decided to have separate designs. One person decided to just put all these 100 records in one cube and create a multi-provider on top of it. And another person decided to split them up into 4. And so the thing is, in your report, the requirement is you want to see all these data, the 100 million records. You want to see all of them for Asia, for Europe, for South America, for North America, all of them. Which of these designs will be better as far as your response time, your query response time? Let's think through let's think through it. Let's dialogue on this. Let's talk on this. So okay, you want to try again?
I'm thinking.
Okay, once again, I'm thinking. Anybody else wants to try that?
The logical partition, a better option.
Okay, why?
Well, since you want to retrieve all 100 million of them, the logical partitioning, you just put a boundary on each region while still retrieving all records.
Can you say that again?
Retrieve all 100 million records, right?
Yes.
If you have all of them, all 4 regions in one input cube, and you partition them logically, you put boundaries on each region, and then you retrieve them versus having them split in, versus having them split up into 4 input cubes.
Yeah.
You have to pull them up differently, separately.
You think that's you have to pull them? Yes, you can't pull them up separately. But what I'm saying is, you want to pull all of them together.
Then the first option is probably better, right? The one with the logical partition, where you have all 100 million of them in there.
Design is better. You're saying the one that has just one?
The logical partitioner.
With the logical partitioning is better. Okay, so yeah. So let's focus on either way. The logical partitioning is better, but I need explanation. Why is that better over one cube with all the 100 records in it?
Because in the retrieval, like if you were gonna pull for North America, the logical partitioning from limited to that region and not go further to South America.
Okay, I'm still not. You're trying to weave your way out, but I'm still not getting. It. Please take it again and make me understand.
Your logical partitioning.
Okay.
You can have a partition where it considers all the regions of North America, and then you place another partition where it captures all of South America, and you do that for Asia, and you do that for Europe.
Let me show you how logical partitioning works. So logical partitioning is nothing than just creating different to logical partition. When you're loading in your DTFI what data you want to send. So for instance, over, let's say your main, right? Let's say your global data. All the data in here is, you have an info object or continents. Okay, and you have all the different continents. You have the Asia, Europe, everything in here. So everything is coming in here to the PSA, all the 100 million records. So you have option to load all of them, the 100 million, into this cube, or you can create 4 other cubes. Okay, and then when you're loading, so the same data source will map to all the 4 of them. And in your DTP, you can specify what to load to which cube. So let's say that in here you want to filter. You do a filter in here, and then assuming one of your objects continent. Let's say source rep ID is a continent. Okay, so you want to put Asia. You specify Asia related data. So when you execute, it just loads Asia into one cube, and you use individual cubes. So all the individual cubes will have data that pertains to their regions, whatever your filter criteria is. And then on multi-provider on top of all the 4. Okay, so that is how to do logical. So logical partitioning is done one time. Okay, so when you have when the query is running, the query can actually pull from all the 4 because your multi-provider is on all the 4. So this is one scenario. The other scenario is instead of filtering the data to different queues, you pushed everything, all the 100 million records over here into this cube. So this cube has all the 100 million records. It has Asia, it has Europe, it has North America, all of them in this cube. Versus the other multi-provider that is pulling from 4 different cubes. Okay, so think of the multi-provider. You have 2 multi-providers. One multi-provider is pulling from only one cube, has 100 million records. And you have another multi-provider that has 4 queues underneath it that have data, split into all these regions. So having said that, which of these during query runtime would make your query response time much faster? Okay, so either way, multi-provider has already been set. You don't redefine the partition during query runtime. Partitions is already set. I'm talking about which of these designs will be better as far as your query response time. Think of it, don't think too technical. It's really simple. Ikea, you have your thoughts together now? Miss Ikria.
Basically, the two scenarios all have the data, but in the logical partitioning, can you restrict some of the data?
Yes, you can. Partitioning, you can restrict it to pull from either of them. But that is not our interest. You can do that, but that is not my question. My question is, you don't want to restrict. You still want all the data.
You want everything.
You want everything. So you have two designs. Split them up and still pull everything into the query, or pull all of them into one cube and then just, So it's just like to say, I'm trying to get access to all of you. You guys are how many here? You are, I think you're 10. You're 11 in class.
13.
Okay, yeah, we are 13 together. And I decided to split our number up into 4 different groups. Okay, so 4 different groups, meaning that one group would have 3, I think 3. So let's say we are 12. So each group will have 3 students in each classroom. Okay, so I can choose to do that, all the 13 of us together in one class. So relating that to the design, you have all 13 of us in one cube. Split into 4 cubes. And question is, all 13 of us need to show in the report. Everyone needs to see all 13 of us in the report. Okay, so you have 2 ways. You can either put all of us in one cube and create a multi-provider on top of it, or split all of us into 4 cubes, put a multi-provider on top of it. At the end of the day, everyone wants to see all 13 of us. Which of these designs will be faster as far as our information, as far as retrieving our information?
Okay, I'm going to try. I think it's the one that has them all together and not split.
Okay.
Because, I mean, you're going directly in for the information, for the data, but you have to go through each one, right? I don't know.
But that's a good one. This is the reason I wanted to dialogue. Because I know that I need to hear your reasonings so that we'll trash it together. What happens, what multi-providers do? So whilst it's pulling Europe, it's pulling Asia too. That is what multi-providers do, or you can even set it to do that. So let's say, you know how when you go to grocery and you have a number of things to pick to your house, you usually you don't pick one bag after the other, right? You probably can pick 2 bags or 4 bags together. And the same time it will move from your car to your fridge or to your kitchen, whether you pick 2 or 1, right? Right?
Yeah. Yeah.
Okay. Giving you the hints. Can you tell me the answer now? I mean, can you explain that to me? Let me take it again. So, you went to do grocery, okay, and have 5 or 6 different bags. You bought different items and they put them into 5 different bags for you. They split them into 5 different bags. You can choose Okay, so my question is specific. Picking one bag, you pick one bag, you go and drop it and come back and, right? So each time you walk from your car to the kitchen, it takes you a minute to walk. Okay, so if you pick one bag, it will take you 1 minute. If you pick, it will take you 1 minute as well, right?
I know what you're saying.
Okay.
Are you saying that since everything is in one cube, that it'll be easier to just get all the data from that one cube?
No, that's not what I'm saying.
Okay.
Okay.
I'm thinking having 4 different cubes might be better because it large cube might be it might take longer to actually get the information, but if you have them split into 4 different ones, maybe with process change, maybe we can the data like at the same time, you know, like in parallel, and then get be able to get our report from there.
Yes. Yes, so that's what I'm saying. And I know I confused you a little bit, but let me make it clearer now. So think about this, and you have 100 million records in one cube. Okay, so let me pull my Excel sheet. So this is cube 1. Cube 1 has 100 million records. Okay, and then the time it will take you to get all these 100 million records is, let's say, 1 hour. Or to pull everything, to get all the data from one cube. And you have cube 2. Actually, let me do this. Let me do and cube. Okay, so you have, let me call this a day. This is a day's cube. A day has 100 million records in this cube. It will take him an hour to retrieve the data from that cube. Okay, and then IKEA decided to do logical partitioning and do 4 cubes. So cube 2, cube 3, and cube 4. Okay. And she split all the 100 million records into different cubes. So that means that cube 1 will probably have 25. Cube 2 will have 25. 3 will have 25. And 4 will have 25 different records. Okay, 25 million. Okay, so do you think that if you were querying on just one cube, this 25 million will be 1 hour? It will not be, right? So math-wise, what will it be? If 100 million records will take you an hour, that means that 25 million will take you what? If less, more divide, right? Divided by 100.
15 minutes about.
So it's going to be what? 15 minutes. So it's going to be 15 minutes. And that means that all these are going to be 15 minutes. So the grocery thing I was explaining to you, if let's say you have these bags, okay, as groceries, and you need to take to the kitchen, and you choose to pick all 4 of them to the kitchen, the walk from the kitchen to your house, the walk from your garage or your car to the kitchen will take you 15 minutes, right, to work, and you decide to hold all these 4 together. So picking all the 4 bags versus going one after the other to pick them up, it doesn't, I mean, it doesn't matter. If you have all the 4, it will still be 15 minutes, right? Right, because you're taking them one time. That's right, doesn't make sense. If you have one bar, you pick, all the time, and you're going to your kitchen, even if whatever time it will take you to pick one, it will still be the same time, it will take when you pick 4, whether you pick 1 or 4, the walk from your car to your thing will not increase. Same walk, it will still be the same distance. It will take you the same time. Does it make sense or it doesn't?
It does, correct.
Okay. I was expecting somebody to come back because previous class when I was explaining it, somebody said that it depends. And it makes, I mean, if you have 4 bags and they are heavy, you probably sleep on the way, right? Or you'll be tired. And you probably slack a little bit. So that may take a little time. Right or wrong?
Yeah, that's what I was thinking. So maybe instead of 15 minutes, it may take 17 minutes.
Okay. So let's say worst case scenario, it may take 17 minutes. What do you think about going each bag, coming? So if each way is 15 minutes, if you go and you pick the bag one at a time, give or take, you're going to still use 60 minutes, right? It doesn't matter whether it's heavy or not, it will still be 15 minutes. So if at the same time will still be faster collectively versus having to pick them one after the other. You pick one, you go, you come back, you pick another, you go, you come back. It will still take longer than 17 minutes. True or false?
True.
Okay. So that means that if multi-providers, you have this, all the 100 million records split into different data records, 25 each, and each of them takes 15 minutes. And you have a multi-provider on top of it that can pick all these 4 at the same time. It means that, give or take, 15 minutes, 15 to 17. Let's say if it's loud, it will be 17 minutes. Let's say it was a little heavy or something, which would not happen if you have, good resources. But with this record, give or take, it will still be an hour. It can't be any less than that. So do you see why this is better? Splitting them up. Do you see the whole logic behind it?
I can see it.
Nice. Anybody confused?
So you're saying the advantage is the multi-provider's ability to do a parallel pull?
Yes. So the advantage providers do, multi-providers, it's an umbrella, a union of different info providers. You can decide to just specifically point it to just one cube. But in case you want all the data from more than a aligning cube, multi-providers do parallel pull. So they pull them together in parallel for you. Yeah. Or here. Which of these places are you making the most of the parallel pull functionality? It's this place. So here, it still doesn't have anything in parallel. It will not use the parallel pull functionality because it is just one provider can pull from. It cannot pull from anywhere else. So it will, but over here, it can parallel pull from all of them. And if each cube is less in data, as far as the data records, it will take lesser than that. The parallel means that you are processing all of them at the same time. You will not go back and come. You pick all of them together. So whatever time it would take to pick one, 4. because the distance from the car to the garage is the same. It will not increase whether you pick 1 or 2 or 3 or 4. So logical partitioning help with query performance. So if you have data, huge volume of data, okay, on the job, it makes sense to partition them to whatever makes sense. You can decide to partition them to regions if that is what your data structure is like, or you can decide to partition them into calendar year. So you can decide to have 2 years of data in one cube, another 2 years. So if you're loading data from 2013, you can choose to put 2000 to 2003 in one cube, and then put 2004 to 2006 in another, 2007 to 2009 in another cube, and 2009 to 2013 in another cube. You split them up into different year groups. And when the multi-provider is processing them, it processes all of them at the same time. Yes, so this is how logical partitioning helps with query performance. Okay, so when you start working and you have huge data volume, split them up and put a multi-provider on top of them. And you will get better. Any questions on this?
Yeah, I have a question. It's kind of sidebar. So, in real life, the job place would expect you to know all this instead of you.
Yes. And bear in mind that they are not technical, so they will not even know what is called multi-provider. They don't even, if you go tell them logical partition, they don't know. They brought you on as an expert, so you need to know these and understand the concepts and know how, you know, objects behave, their functionalities, and know when to use them. So yes, it's our responsibility. For instance, on my current history, and they have years of histories from whenever they began their business, and they've been in business for years. But we don't want to load everything. We just want to load history, 5 years of history. Okay, so 5 years of history is a lot of records. We don't want to put them all in one queue because it's too much data. So what we did was we put all of them in one 5 years records in one DSO, and then from the DSO we split them into, I think, 4 different cubes, you know, pertaining to yearly, each year with each cube. Each year would, you know, have it 1 cube, each year will have 1 cube in that. So we split them into 5 cubes. But the whole data, we wanted to acquire them in the DSO state, like have everything into the consolidation layer and then just split them up. Because anytime you need to report over, you can specifically point the multi-provider to 1 cube, to whatever year you want to see, or you just run it wide open and it will do the parallel pool for you. And it's still much faster versus putting all of them. Any question? Logical partition and multi-provider go hand in hand, and selling point is their parallel pool. Okay, parallel pool, you know, different data in less time, or the same amount of data in lesser time. And you know, so that this is multi-provider again. And we've already created a multi-provider, right? You guys know how to create a multi-provider?
We've gone over it, yes.
Yes, we have. So, yep, that's all there is. Yep, so multi-provider enables the parallel pool. So good candidates for query performance. Yep, so that is all there is to query. I will not say that is all there is to it, but this is the main things you need to know as far as query response time. It's your aggregates, compressing your data, pre-calculating your result set in OLAP cache. You can do RSRT to define your query. You do want the data to run, once or only when you're navigating. What else did we cover? Your logical partitioning with your multi-providers. These are the main selling points for query performance. Okay, and the other things I can add to is will be your decision to using multiple providers over an if so. Depending on the nature of data, if your data is more detailed, all right. If it's summary, you want to use your cube to do your reports. It's better. It will enhance performance better. So it's not good. It's not good for performance. The fact that it may not give you accurate results because of its functionality. It will also take longer for your data to, run, because if you're using right optimized DSO, your sets will only get generated upon query runtime, only when you execute your queries. Because we already know that you don't sets do not get generated. But since you need your sets in reports for your reports, it will have to be generated during your query runtime, and it will take. So never report off a right optimized DSO if it's not necessary. That is not good for performance at all. Okay, or you can choose to create your sets before even reporting of it. So these are the main performance are concerned. Any questions? If there are no questions, we'll take it. We'll come back and then finish load performance. And when we are done with load performance, we can. Or rather, let's finish load performance, and then we'll take a 10 minutes break, and then we'll come back to our talk that I know you're all very interested in. Okay, so let's officially end the class, and then we'll come back, and that part will now go into the recording. So data load performance. Are you guys or you have questions on any of the query techniques? Okay, if you don't have any questions, the next performance tuning technique is as far as your data loads. And all that means is that how quickly can you load your data? And I'm sure you've all had a fair share of performance as far as data loads are concerned. I'm sure you've tried loading data from ECC and it's taking forever. Something that can happen in a minute takes forever. There are a number of reasons that can cause that. And one of you sent me a screenshot of an innate info package, and you were getting some shutdowns. Can you imagine that happening on the job? That will impact. You cannot have your data in because system is not behaving properly. So that was why when I was starting, I was saying that was a collective work we all do, not just BW people, but business guys also play their fair share in the whole process. Okay, so a good thing that one of the main things as far as your load performance is how good the system has been set up. Okay, and anytime you're loading data, data comes in data packet sizes. In data packet, info package, I think you see that, and we can go into your into EC. Oh, this is a flat file. Okay. So, so you see over here, size in here. By default, I think it comes in, the DTP will come in as 50,000 by default, I think. But you can specify whatever size you want to load your data in. Okay, so you can set your data packet size. And let me see. Anybody done business content? Let's see if I can find.
Yes, I try to do, but it gives the system errors. Yeah.
It gives system errors, right?
Yeah.
System issues like that. You can get this on the job. It happens a lot. You can be doing something, you get shutdowns. Anytime you're faced with that, always contact your basis guys, because they are responsible for that. And that is also a kind of performance. It's not behaving well. It's probably how they've done some settings or something. So anytime system is misbehaving on the real job, get in touch with your basis guys and they will fix that. Let me see if I have any business content. Anyway, when we start doing real projects, you see that. But as far as load performance is concerned, just understand that you can set your packet size, okay, for data to come in exactly the way you want it to come in. By default, I think it's either 10,000 or 50,000. It's one of them, but I'll verify for you. So you can change that settings, and you can change it from ECC or even in BW. So however number of records you know in your data packets, you can predefine. You know, because sometimes you realize that I've had people call me, they were having issues and was complaining about the sizing. It was pulling 50 records at, per time. Reduce that size to 10, depending on what your system capability is. If you reduce it to 10,000, it will probably load it faster for you. So depending on what you see, you can reset the data packets. Okay, and another load performance things I want to talk about is your other DSOs. Okay, so we all know that right optimized DSO at one table, which is the active data table, you don't activate data. So that activation of data takes time. So that means that if you want to quickly get data into BW, just into BW for your acquisition layer, most companies or most people use the right optimized data is available. Okay, you don't have to go and activate data. It can be pushed to, you don't have to activate it. So the activation process is ignored, and that's, some people can argue. I've had arguments on, on the job with my teammates on which one to use, and each use. But it's just know what they do and you decide which one you want to use. Okay, but people usually use right optimized DSO for acquisition layer because it's faster to get the data in because you don't have to activate the data. Okay, if you're going to use that for reporting, remember that you have to flag it for reporting. When you flag it for reporting, what it means is that it will generate this. Don't generate sales. When you don't activate, sales will not get generated. Okay, and since you don't want to generate the sales during the query runtime, because whether you like it or not, the sales will be generated when you're reporting of it. It will generate during query runtime. And would you rather have the sales generate during the query runtime? That would take extra time. users will now wait for that. So rather have that generate at the back end so that the query response time will be faster. Okay, but we are not talking about what end up doing is that they can flag the flags off. So when they set it to report, they flag it for reporting. That means that they only want it to run, to generate at the query side. But that is also not good. So when you turn it off, when you're loading, it will not generate. So your loads are much faster. Okay, and this means that sets are generated when flagged, which in turn affects the load time. So when, for instance, if you are loading data into a standard DSO and a write optimized DSO, you will finish getting data in your write optimized DSO, standard DSO, because with the standard DSO, when you're activating the data, it will generate sets, and sets generation takes time. Okay, so if you want to turn that property off, you don't want the sets to generate, you can turn it off, and the load process will be faster. How do you do that? It's just going into the DSO and just turning that functionality off. You don't have any DSOs? When you go under settings, over here it says set generation during activation. Do you want it to generate when you're activating? But I think by default it goes. If you don't, you can do never create sets or only during reporting. When you do during reporting, remember that it will only be good for you as far as your loads are concerned. But when you're reporting of it, it will not be good. You're not going to report of it. And if you do never, sets are good, right? They also help. Without sets, how are you going to get access to your master data tables? You will not. So you have the option. You can turn them off and turn them back on, or never, or whatever suits you. Or you never want to have sets for whatever reason. You can choose that. But this is where to turn them off. If you turn them off, the load performance is much better. Okay, so this is as far as DSO load performance. Another load performance thing that is another serious one is ABAP. ABAP is nothing but your routines, your coding, your program you have designed or you have coded in your objects. Okay, so sometimes you can have cumbersome or very complex, so if you don't optimize those routines, it would actually slow down your load process. If you have so many routines, doing so many things, routine picking stuff up from different places, calculating them, doing fancy stuff to them, and you don't need them, why have them? Because it will slow down your data loads. So you want to make sure that whatever routines you have in between your data loads, you optimize them very well. It will quickly be loaded for you. Always make sure that before you load data, you delete indices. If you don't, it impacts performance. And you can automate all of them in your process chain. So there's really not much to load performance. Other things you can do is you can actually buffer your sets in memory, or you can do number range buffering. And that means that you're just storing them in memory. So that anytime the system is loading, you've already calculated your sets in memory or your numbers in memory. So it just assigns, numbers easily, without having to calculate that on the fly. You can do all those settings as well. As far as your load performance is concerned, it's mainly about your packet sizing, your max and main limits, your use of write optimized DSO, being optimized. There is not too much to it. The other ones will come into the picture, you know, henceforth. So let's create you a good process chain with what a typical process chain design would look like. So, you know, officially end the class. So if I was gonna copy, I thought I actually had a process chain right in the other. Let's work on that. So this was what we created the other day. Okay, we did so many things to this. So a typical process chain with performance, you know, you want to automate all your performance techniques, and it will be, no, so over here, before you start loading to your PS, or even into the PSA, it's fine. But before you want to push to your target, from PSA to target, you want to make sure that you delete any indices that are already there. Then it will take time, the load process. So you want to, you can create a variant for that. You can do z delete. You can do delete. Delete indices.
So can you create indexes for DSOs, or it's only for the InfoCube?
Yes, you can create it for DSOs. And indices actually help with DSOs. Like if you want to, you know, all the things we've talked about, like aggregates and compression, I said were specific to cubes, right? You have too many things you can do to it. But indexes is one of the strongest things you can do as far as DSOs are concerned. If you want performance on a DSO, you can create an index on it, and it will make retrieval much faster. And I'll show you how to do it. Typically, anything that is defined as a key index, you can redefine secondary indices for that. So over here, you can do your cube object type, because we're loading to a DTP. DTP, so that you can do your name. But let's do the cube. You can put your but that was not a cube. Another cube. So let me just do this. So that's about it. And then you can inculcate this in the process. Can you be on mute, please? If you guys are on mute, let me finish this part, and then you can unmute yourself. Okay, so in here, anytime you create a variant for, guys, can you mute your phones, please? Okay. Thank you. Anytime you create a variant to delete your indices, it automatically knows that you have to recreate it, because you're only dropping it for performance reason, and you need it. You need indices for query performance. Okay, so deletion helps for queries. So you want to split them up. Like you don't want to have them all, you know, side by side like this. So split them up. So you put this process over here. You want to delete your indices before you load, right? If it helps with loading, why not delete it first? So upon successful deletion, you want to map it to your DTP. Sorry, to your DTP. So once you start your process after PSA, you can just matter. But if you choose to put the deletion before PSA, that it only impacts the load to the target. And then once you delete it, you load to your target, And then if your target is your DSO, you have to activate it. Activating it, you push it to your cube, and once it goes to the cube, you want to recreate it. So now you recreated it together. So you've added a deletion process. If you want to automate your roll up and your compression, so you want to do this. You want to do roll up. You create a variant for that. So you want to do Z roll up. And remember that we said roll up data from your cube to your aggregates for you. So you want to choose your cube. I don't remember the cube. You want to roll up. I'll do older than 0 days because I want the data to be pushed right away into the aggregate. Because if you don't do that, it may not be the reports for you. So I want to put anything older than 0 days. That means anything that is today, push it all the way up. Save it. And where does it make sense to fit it? You want to fit it right after the DTP load to the cube, not the DSO one, right? You want to fit it right here. So you want to remove this link. You want to put it over here. Immediately, you want to do a roll up. So roll up comes here. So once you're done with the roll up, you can do a creation of index doesn't matter, but last. And I can also want to compress my queue, so I can do compression, create a variant for compression. So Z compress. And you can specify a number of queues to compress in one process. You can put so many queues in here. If you want to compress 20 queues one time, you can do all that. So over here, you choose your object. And remember that press only when you have validated records. You want to give ample time for you to validate your record. So let's say older than 14 days. If there's anything that is older than 14 days, or let's even do 30, 1 month to be safer. Okay. And then you realize that a compression it's put it after the create. So I did brought its own, when I did a compression, it brought its own flow. So usually anything it proposes, that is the best sequence. So you delete, you create, and then you collapse. Collapse will be the last process. Okay, but I already have these, so I'm gonna remove them. I'm gonna remove that. So I'm gonna recreate this before I compress. And then my final step will be to compress the data. Okay, and I'm going to activate it. And then this is the request. We already know this, right? So it's prompted a request. I can create a new one. And then continue, and then post in that request ID. So over here, it's complaining because it's not saying the queue. And it's good to pay attention to this. See what it says over here. It says that deleting this process can be in front of process rollout, I guess. No type generated numbers are allowed behind. Okay, index process allowed behind process roll-up. So you cannot have generate indices after your roll-up. So that means that you want to generate it first before you roll up. Okay, so this is a good error to catch. So some processes can only be before the other or after the other. Having independencies, it doesn't matter. So we're going to have to switch them around. So after the DSO activation into the queue, we're going to generate the index before we fill the aggregate. So this has to come first. Generate the index, and then right after the index we can fill. And let's try activating it now. There's no predecessor, I didn't map it. Okay, so it's lane idle. So we're gonna map it to the last one, which is a fill line. Read it now. Active. So let's see how the whole process is like. So this is a very typical process chain. Okay, immediately you start, you execute your info package, you delete your indexes in your cubes or wherever you want to delete it from. You run your data target load to your data target. If it's a DSO, remember that the next step should be you have to activate your DSO. If this doesn't come, you will not be able to update it to any target. Activate this, and then the next thing will be the process that pushes it to the target. And then once since you already deleted the data, immediately goes to the target, you want to create it. So load to target, and then if you have an aggregate on the cube, you fill it. You know, you do a roll up. Then once you're done doing a roll up, you want to compress. So all these are just performance, but you want to automate them. You want to compress your cube every 2 weeks, every month, whenever. And it's a typical chain. Any questions? Any questions so far on performance?
I have a question.
Okay.
What's the difference between a so that you don't write SIDS to versus a write optimized DSO?
What is the main difference?
Yeah.
I think we covered that, right?
I guess my question is,
go back. Oh, is that a performance? Yes. So that was what I said. Anytime sets are generating, it takes longer. It takes longer for sets to generate because it's an extra activity you're doing, right? So if you have a right optimized DSO that does not generate sales, it's much faster. So if the time it takes to generate 20 records is 5 minutes, 100 records is times, or 5 times 5, whatever it is. If it takes longer to generate sales and you don't have to generate the sales, then that is extra time that is saved. So that is where the performance comes in. Because all we are talking about, all these performance in is regard to time.
So is there a performance difference between a standard DSO that has its SIDS turned off versus a right DSO, right optimized DSO?
Very good question. Very, very, very good question. Thank you for that question. So what he's asking is, you can have a standard DSO. We've all said that a standard DSO, you have to activate the data, right? So when you activate the data, SIDS will get generated. So if you want to have a better load performance, you can in the DSO. So his question is, how is that different from a right optimized DSO? Because a right optimized DSO will not have SIDS anyway because you don't generate data. You don't activate data. So how is a standard DSO that does not have the SIDS on versus DSO? What is the difference?
Then you have to create, the SID will be generated when you run your queries, so it will also affect.
Yes,
for the
so
standard DSO.
That is one. Can anybody else say anything? Okay, so I can't say difference when you turn off this DSO. What you have done to that is it is not any different as far as the SID generation different from the right optimized DSO. But which of these two processes will still save time? It's still the right optimized DSO. Because even though you have turned off the flag, you still manually have to activate the data. Okay, so this is what happens. Do I have a DSO here? System. You have this queue, right? So let's say you have 2 DSOs. Let me see if you have data here. Okay, so there's data over here. So if you do not activate it, you will not be able to update it to whatever target is on top of it. No matter whether you have turned on the SID or not. If it's a standard DSO, you definitely for sure have to activate the data before you can further update it. With a right optimized DSO, you don't have to activate the data. Okay, because data comes in already activated for you. The only difference is when you flag this, you change the standard DSO setting. Right here, activation, you turn it off. What happens is activating the data. The activation process you still have to do, but the activation process will be faster because SIDS will not get generated. But so still, there is a difference between the standard DSO that does not have SIDS turned on against the right optimized DSO. You don't have to activate at all. The process will take another minute. It's still not good compared to the right optimized DSO as far as the time is concerned. Did I answer your question? So still, with a standard DSO, whether it's flagged or not, in comparison to the right optimized DSO, you still need to go through the activation process, which is extra time. Make sense?
It does. But if you put it, the standard DSO in your acquisition layer, and you've already activated it, is there a big performance difference between the right?
Can you say that again?
So after you, so let's say you put a standard DSO the SIDS,
Okay.
and you still have to activate the standard DSO, right?
Okay.
Is there still a huge between the standard DSO with the SIDS off and the right optimized DSO?
As far as performance, and it's people can argue, I can argue for both and against both. Okay, so it just depends on your environment, the kind of the data, the nature of the data, and everything that is going on. But let me give you a general view on things. So what you're saying is, in acquisition layer, you can choose to use standard DSO or right optimized DSO. So if you choose to use standard DSO and turn off the flag, how different is it in performance to the right optimized DSO? It is still very different, but somebody may choose to use right optimized DSO in that. Somebody else may use standard DSO in acquisition layer and just turn off the flag. I've used both before, depending on the situation at hand. Okay, so right optimized DSO, some people argue it out as another PSA, but you can store data in that, more, that can be more permanent than a PSA, because PSA over time it grows and you have to delete the data. DSO to a right optimized DSO, as far as which of these two can store data more permanently, that it will not grow too much system performance. It is a standard DSO. Okay, so you realize that some people don't even like writing much or for acquisition. So they would rather use a standard DSO, and because when they have that, they can store data in a standard DSO forever, and they will not impact performance. It will grow exponentially, but the right optimized DSO will do that. And some people can also argue that, well, why do I want to, turn off the flag and still go in there and activate data? I'm too lazy. I don't want to, after I'm downloading, I want to be totally done. I don't want to go in the DSO and activate the data again. Even if it will take 1 minute or 2 seconds, it's still another activity I have to do. I don't want to go through that. So with that, I'll just go with my right optimized DSO. Either way, you can win your case with either. You can win, either or. But as far as time-wise, it totally depends on a lot of things. But, to answer you and to give you a simple answer, they act like the only difference is that with the standard, you have to manually go in there and activate the data. And that is an extra step, right? But you can get to keep more data, keep data on a more, longer with the standard DSO that is flagged, that you've turned the flag off, versus the right optimized. So it depends on which one you want, what works for you. It's a give and take thing. Does that make sense? Anybody, does that help? Did that?
Yes, thank you. It helped.
But that's a very, very good question. I like that question, because really this is what we all do on the job. We argue a lot to win, but we dialogue a lot of reasoning before designing. You realize that some of my data flows right now, my current projects, some of the DSOs we're using at acquisition layer is the standard DSO, because the nature of data, or the functional area, make more sense to use a standard DSO than right optimized DSO. And some of them we just use the right optimized DSO. Some of them no DSO at all. Things go on in determining what to use or not. All right, any questions on performance? If there are no questions, that will be the end of performance, and that will be the end of the class today. I will pause the recording. We will take a break for 10 minutes, and we'll come back and just round everything up together. So any questions? Any other questions, guys? If there are no questions, I know it's a lot to process right now. You take your time, in your own pace. Weeks, last classes video compared to anything that I didn't mention here that I mentioned in the previous class. And this will not be the last time we are meeting or you're hearing from me. We will be meeting occasionally. So you will definitely have everything you need. So having said that, if there are no questions, we're going to stop the recording and we'll break for 10 minutes and come back. Kofi, are you there?
So you want to pause, right?
Yes, can you pause it? I think we've ended.
You ended?
Yes. Any questions, guys, before Kofi pauses it? And that sure didn't sound like Kofi. Kofi, were you the one that just spoke?
Well, was that, you said what, was that the one that just did, what?
Oh, yes, you sounded very different. Can you just stop the recording?
Okay, so we wouldn't record again when you come back? Or we would?
No.
Okay.
We will not.
Okay. All right.